All right, we might be slightly behind schedule, so I'll try to be as brief as possible. First of all, thank you so much for joining us on behalf of Carbon Gap and Deloitte for the launch of the report. Maybe just to get right into it, I think we all realize that decarbonization is difficult. It's difficult technically, it's difficult politically, it's difficult commercially. There is no silver bullet. There's no PowerPoint presentation that's suddenly going to get us to magically remove all the carbon from the atmosphere. Um, while Europe has set a target, which is climate neutrality by 2050 and negativity thereafter, target setting is the easy part. The harder part is figuring out how do we actually get there. I think most of us know that we need to focus on decarbonization first and foremost. There is no way of avoiding this. Carbon removal should not be a way to say, hey, look, decarbonization is difficult. We're just going to offset. Now, if we are serious about net zero, more broadly speaking, we also need to be serious about carbon removal. Not as a distant theory, nor as a side market for companies that have larger than average sustainability budget, but we need to take it seriously as a real infrastructure, climate, and industrial policy area. So this is very much where the intersection of where scale is possible comes in. And what I really like about the work that Deloitte has put together is that they don't start off with this abstraction. What they start off with is sectors that are real, physical, and already regulated. In this case, wastewater, concrete recycling, and mining waste. Typically, these sectors don't dominate climate headlines, but they matter because they actually move materials, they sit in communities, they operate under rules, and they also have very, very long investment life cycles. The core idea of the report, and I'm not going to try to spoil it too much, is that while we shouldn't just say, hey, we'll buy removals at the end, it's very much about what are the areas, the sectors we can already embed removals today. Wastewater treatment can be more than water quality and public health. Mining waste can be more than a liability, and when it comes to, now I'm forgetting one of them, concrete recycling can be more than circularity. There we go. Under the right policy frameworks, we can actually unlock these sectors and make them part of Europe's carbon removal capacity. What I was really impressed with Deloitte's contribution here is that they go from ambition to implementation. This report looks at technology readiness, it looks at CapEx, OpEx, site realities, it looks at cost down pathways, it looks at certification, first of a kind finance, all the nerdy stuff that many of us in this room live and breathe for. In short, it moves the conversations from targets to systems, from ambition to delivery, and theory to balance sheets. And the climate potential here is actually quite meaningful. Based on the sectors in mind, if you scale this globally, these sectors can remove between 250 and 350 million tons of CO2 per year. And I think that's quite meaningful. Of course, this is not the whole solution, but it is a contribution to making CDR happen and taking us from targets to something that's a bit more operationally real. And today, we're going to talk about pathways that are not speculative. These already exist, they already operate, they already scale. And today's agenda very much reflects this. So what we're going to do is we're going to first welcome Deloitte, who's going to go through the report, walk us through the key findings. Afterwards, we'll have a couple of companies showcasing their ways of integrating CDR. Then we'll have a very short coffee break. And then finally, we'll come back in for an expert panel. And then we'll continue the conversation over some light refreshments. Now, the title, No Wasted Opportunities, I think is more than just a slogan. It is very much a discipline. We are at a time where we cannot afford wasted emissions, wasted materials, or wasted policy windows. So without further ado and wasting more of your time, I'll introduce the real people who made this thing happen, Deloitte. And yeah, the floor is yours. Thank you.
All right. Can you all hear me well? Perfect, perfect. Thanks a lot. Thanks a lot, Alex, for the kind introduction and also already giving a quick summary of our report. We're very happy to be here today and present the key insights of our study to you. So I'm here together with Audrey, so we will take you through our presentation. And as already mentioned, so the title is No Wasted Opportunities. So what we're going to do together with you today is have a look at the carbon dioxide removal technologies, CDR as we call them in short, and the opportunities of those in three sectors, being the wastewater treatment, concrete recycling, and mining waste management. So in short, what we will do is first give you a quick introduction of why we started the study and why carbon dioxide removal is important. Then we're going to have a look in those three sectors, so wastewater treatment, concrete recycling, and mining waste management. And then we're going to end with the policy recommendations that we have in the study, as well as the conclusions. And as mentioned, so we have a full report out there. Normally it should be launched to you today, which you can find online. And yeah, basically what we will present to you today is only some key insights. So the content table of the report, as you can see there, it's basically the same as what we will present, but it includes all the details of the report, of course. So yeah, after the presentation, if you're interested, go and look for it and find out all the details that we have there for you. So first, introduction. The project was set up by our Beyond Value Carbon Mitigation Program of the Deloitte North-South Europe. Basically what this is that Carbon Gap initiated the project, but they asked for funding from our program, and the Beyond Value Chain Mitigation Program of Deloitte, what it does, at Deloitte we're not only looking at lowering our emissions, but also at looking beyond the value chain. So it means they are looking into buying carbon credits, but also doing projects like this that accelerate the whole societal decarbonisation. So that's also what this project is about, really looking at what these sectors could do for decarbonisation and specifically carbon dioxide removal. So carbon dioxide removal, we have it here on the slide. What is it exactly? It's human-led activities that are really extracting carbon emissions from the atmosphere and storing them. And in this study, we're looking to store them for a very long time, so almost permanently, so high durability CDR as we call it. And why is this important? Well, it's basically one of the pillars to get to net zero. And we have carbon capture and storage, which is also very important today. And this technology is looking at preventing emissions to go to the atmosphere. But carbon dioxide removal is really extracting emissions from the from the atmosphere. So really lowering the emissions we have there. And like this, it's one of the central ways to get to net zero. And that's also mentioned by the IPCC in their assessment reports, in all their scenarios. They really say that this is one of the ways that we need to get to net zero and staying within the 2 degrees increase by 2100. So carbon dioxide removal, important to get to net zero. What we did in this study is to have a look in those three sectors: wastewater, concrete recycling, mining waste management, and see which opportunities are there, but also to have a look at the policies that are in place in these sectors and what we could do there to really deploy these technologies that we will look into with you today at scale and preferentially fast. So 3 sectors: wastewater, concrete recycling. Why did we look at those 2 specifically? Well, basically those 2 sectors, they treat very high volumes of waste streams, as also Alex mentioned, but also they are treated domestically. So it means that even if we would deploy carbon dioxide removal technologies in those sectors, and it would add a little bit of costs to the treatment, it's not that due to that little cost increase, those waste streams would go to another continent to be treated. They would still stay here, they would be treated, and they're also heavy regulated, these sectors. So basically they would be able to bear that ask if we would ask it from them. And then for the mining sector, that's very obvious. Critical raw materials, very important. The demand will increase a lot over the next decades for all the clean energy technologies that we need. So if you want to secure your own supply chain and you're setting up new mines, you could also directly have a look, can we include carbon dioxide removal technologies in this sector? So with that, I would like to now give the floor to Audrey for the wastewater treatment.
All right, thank you, Gino. I hope you can all hear me well as well. Okay, great. Now we'll dive into the different industries, three of them, that we did really a deep dive on in the report. So as Alex mentioned, the really nerdy stuff, now we're getting into it. So within the sector of wastewater management, overall, we see that within the EU, 40 billion cubic meters of wastewater is produced every single year. Treating this wastewater accounts for about 25.5 million tons of CO2 each year. And then, if you have a little side note on this, this does not include biogenic CO2. So, important thing to keep in mind. Now, if we look at the capture potential within this industry, there is a potential of capturing 16.6 million tons of biogenic CO2. Now, if we look at how this is actually done, what are the technologies that would enable this? We have the image in the middle here that is summarizing the most generic urban wastewater treatment plant process that we see today. So I will try to do it with the pointer. There we go. So as you can see, first, water is produced by households and industries. And then, as we all know, through the sewage system, it's going to the wastewater treatment facility. Here, the wastewater undergoes several processes. The most notable one is the secondary treatment process. This is where microorganisms essentially break down the organic waste, the organic matter, in order to purify water. With this, we have three major greenhouse gases that are released. We have, first of all, biogenic CO2, methane, CH4, or N2O. Within this process, there is an opportunity for CDR. It's called alkalinity enhancement. And what we will actually do is we will add alkaline materials to the tank in which the secondary treatment step is taking place. What will this do? For example, we have the alkaline material limestone, the most used one. It will react with the CO2, essentially sequestering the CO2 within the wastewater. We also had a look at, okay, what will this now cost to add the limestone into the wastewater? And here we see, for a capture amount of 4 million tons within this process, a cost increase of about 4.3% of the treatment of wastewater only. And if we look at the entire value chain of treating wastewater, but also making new drinkable water, this would increase the water bill by not even 1%. And for an average user, this accounts for €3. Now, adding alkalinity or limestone to wastewater does not only have a CO2 sequestration benefit, but it also has other co-benefits. It increases the alkalinity of the water that is then excreted from the wastewater treatment plant. And this then has positive impacts on, for example, biodiversity of water streams, rivers, etc. It also can make that wastewater treatment plants operate in a more efficient way because the microbes are better equipped or in a better environment to do their job and to purify the water. So that's for the secondary treatment step. Now, at the end of the secondary treatment step, we have some residue that is floating to the bottom of the tank. It's carbon, but also some microorganisms. And this is what we call sludge. And this is where we start the next slide. Sludge typically is also managed in different ways by wastewater treatment plants. Here, the two main streams that are most commonly done today are we are producing biogas through anaerobic digestion of this sludge, and this sludge is and this biogas is then combusted to produce electricity or heat. On the other hand, sometimes sludge is in itself also incinerated. And we see these three elements have CDR potential in that during the biogas production, we can upgrade the biogas, extract the CO2, and capture it. And then during the combustion of biogas, you can also capture CO2. And during the incineration of sludge, you can also capture the CO2. And here, captured CO2 can be sequestered in deep geological storage or other more localized storage sites. Alternatively, we have the sludge that can be converted into biochar or bio-oil through a process called pyrolysis. And here, there's two options. Or it's stored underground, or it can be used to be spread on agricultural fields due to its benefits for agricultural soil, etc. Now here as well, we see some potential co-benefits aside from carbon removal. For example, we recycle the nutrients of the sludge. We recover energy through biogas upgrading and the combustion of biogas. We remove long-lasting chemicals through incineration or pyrolysis. And if we put biochar on agricultural fields, we have increased water retention through this process. And of course, and this is something wastewater treatment plants also care about, is in the end, what can we do? We can reduce the cost of managing sludge. This is all in theory, but we see companies that actually already do this. We have two people here who will talk more about it later on. So we have Avizet, Omia, and Crew Carbon who cooperatively are doing already alkalinity management. And then we have CO2 that is captured at a wastewater treatment plant that is already being stored at Northern Lights. So pretty interesting stuff. Now, theoretically, wastewater, very large process, a lot of opportunities for CDR. For concrete waste recycling, it's a little bit more straightforward. Here we have, if we take a step back, 230 million tons of concrete waste that is generated each year. Recycling this concrete waste accounts for about 2.3 million tons of CO2 every single year. And again, if we look at the capture potential, here we see 2.3 to 5.7 capture potential of CO2 every single year. Now, again, how in the process will we do this? What are the technologies behind this? Here we have concrete waste that is demolished from buildings. Typically, they're sorted, transported, crushed, etc. And in the end, we get a product called RCAs, recycled concrete aggregates. These recycled concrete aggregates can be mixed again with additional virgin raw materials to produce new concrete, or it can be used as a base material for road construction. Now, where does CDR come in? Here, CO2 can be captured from biogenic sources. It's transported to the concrete recycling plants, and here it is made to react with these recycled concrete aggregates. Then we have the output of this, which is enriched CO2 enriched concrete aggregates that can be used again as a material for road construction or same used to make new concrete. All right, again, what does this cost? We made a calculation, an estimation that to produce new concrete with these RCAs, we would only look at a 1.1 or 2% increase in production costs. And if you look at it from an entire concrete building lifespan, the cost increase would actually be negligible. And then we also have someone from Neustar here who will tell us a lot more about what they're doing. But this is just to show you that there's companies that are already doing this type of CDR. And now I will give the floor back to Gino, who will talk about the mining waste management sector.
Thanks, Audrey. All right, let's have a quick look into this one as well. So mining waste management sector. So what are we talking about here? So in the EU, 500 million tons of mining recurring waste is generated each year. That's actually 23% of the total waste volumes in the EU. Of course, all that mine waste is not directly applicable to carbon dioxide removal. We see that there are some minerals that have much more potential than others. for example, nickel and platinum group metals have a lot of potential for carbon dioxide removal. And nickel, for example, if you look at their tailings by 2030, based on also the increase in demand that we expect for the clean energy technologies, we expect that only this waste stream could go up to more than 600 million tons by 2030. So that's huge. That's globally, of course, because nickel mines, yeah, they often operate globally. It's not that we have one in each country. The sector emissions, if we look specifically for nickel, we see 50 million tons was emitted in 2019. That's scope 1 and 2 emissions of that nickel waste. And if you look at the carbon potential that we calculated, so the CDR potential, there we estimated in 2020 alone, annually, that would be around 100 million tons theoretically that nickel waste could store. So how is this working now in the value chain? That's why we also have here that figure in the middle. So the mines, they are produced at the starting point, and then a lot of waste is produced at the same time. We're talking about slag, waste rock, overburden, and then the mine tailings. And all of those are either stored in heaps. You have the backfilling, land reclamation, and then that could potentially also be used in construction projects. And we also have here Anglo-American. We'll talk more about that later. But they're also looking now at a new application, being the enhanced rock weathering with that mining waste. But basically what you could do, and the tailings have the most potential because it's very large volumes, and they also have a lot of alkalinity minerals in them. So, and they can absorb that CO2 and store it almost permanently. And if we look here from an economic perspective, if we would store up to 10% of the weight of those nickel tailings, for example, we see that there the cost would increase by 20%. So that's significant, but we didn't include the sale of carbon credits. Potentially, if those final materials that are produced from that are used for new applications, there we also didn't include any revenues. So it could be lower if you would include it. And also, if those technologies scale up and they become more mature, potentially costs could also go down. For the platinum group metals, we're looking at 6% cost increase to store 10% of its weight with CO2. And also there, you could choose to store less than 10% of that weight. So that's also a choice a company can make. But at a product level, here we chose already a product which is very rich in nickel, the NMC battery used in electric vehicles. Although today we're also looking at LFP batteries, but the NMC battery, there the cost would increase by 6% based on the 20% cost increase of nickel production. But there's of course many other products that include nickel elements and platinum group elements with much lower contents, and there the end product increase would be much lower. Here we also have two examples on the slides that are already doing this today. On the one hand, we have Arca. They have this kind of rover that is churning that mining waste to increase the exposure with atmospheric CO2. But we also have Anglo-American, and you will see, you will hear more about them in their case study in a bit. And they're looking at enhanced rock weathering, so using that nickel mining waste on agricultural fields, which on the one hand is capturing CO2, but on the other hand is also increasing the soil properties, improving the soil properties, which can help farmers with their fields to increase their production. So as a conclusion, we looked into three sectors: wastewater treatment, concrete waste recycling, mining waste management. And here you have all the key figures. So we're talking about huge waste streams that are already being treated there today. If you look at the sector emissions and comparing that to the carbon dioxide removal potential, we see that it's almost at the same order of magnitude in each of the sectors and can even go beyond. And if that potential would be fully realized and fully utilized, that means that those sectors could become net negative in the future. Policy recommendations. So for those three sectors, we also looked a bit at the limitations, what is preventing them to reaching that large-scale deployment, as we summarized them on this slide. So on the one hand, it's often also linked a bit to a lack of knowledge on which benefits these CDR technologies can bring. So on the one hand, the GHG emissions, a bit of research could be done there to improve our understanding there, but also all those co-benefits that we explored in the slides. More knowledge there would help improving the business case. Then we have the GHG inventories accounting frameworks. What we see there is that these CDR potentials and the GHG emission reductions that they give, they're not always included very well and easily in those accounting frameworks. So we think that there some improvement can be done as well. And then we have 4 limitations linked to the financial side. So on the one hand, yeah, we see that there's not always a lot of financial support from governments to set up first-of-a-kind projects in these sectors. Yeah, the end users are not always willing, of course, to pay a bit extra for those CDR technologies. And together with absence of mandates, this can cause low market demand. And then most of those technologies also have a link with CO2 infrastructure. And it's, of course, an early market. There's not much CO2 infrastructure out there today. So that can also increase the costs when you want to start up such a project. Policy recommendations. We have 2 sets of policy recommendations in the report. On the one hand, facilitating measures that can improve the business case of CDR projects. And on the other hand, embedding CDR policy making. That's on the next slide. So facilitating policy measures, what we have here. So on the knowledge, so we think, yeah, there could be extra research being done to really unravel all the GHG benefits that can be achieved with those technologies, all the co-benefits they can bring. We also have listed a bit of the co-benefits here on the slide for the 3 sectors. Then extra funding to set up these first-of-a-kind projects, as mentioned. We think it could be done with a blended financing strategy. In the beginning, it could be rather in the form of grants, because those technologies need to become more mature. But when the business case is there, it could also be loans that the governments could give to companies setting up these projects. And if you look at the scale, we believe that yeah, the capex needs of those projects, we don't think it's huge amounts to set up such projects. It could be below than 1 million, even up to 5 million. And we believe with that you could set up such a project. Monitoring and accounting in GHG emission accounting frameworks. Yeah, try to include all the GHG emission benefits these technologies can give and make that easy. So national governments, when they have such projects, but also companies, they can easily fit that in the existing frameworks. Here we specified that also per sector. For example, in wastewater, often only being looked at ammonia, methane, not CO2, and even wastewater treatment plants can have some fossil CO2 there, but mostly the biogenic. So if that would be included in those monitoring frameworks, that would be great. And also the carbonation and the mineralization, concrete recycling, mining waste management is not always included in those frameworks. And then the last one is on the purchasing vehicles. This is more and more looked into for carbon dioxide removal projects. If they are being set up, for example, at the EU level with the CRCF, we believe also important to take into account those sector-specific CDR technologies, make sure that the certification frameworks are there for them. And if there is really a purchasing program, there could be a portfolio approach applied so that not all money goes to one technology, but it's driving innovation in all kinds of CDR technologies. And then, okay, one button here. Then we have the embedded policy making. In brief, what we mean with that is these sectors, as also Alex explained, are very regulated. So they have clear legislations that are asking from them, what do you need to do, what do you don't need to do. And so here there could be mandates, as we call it, included in them. For example, wastewater treatment. You have the Urban Wastewater Treatment Directive. Today it's already asking mandatory monitoring of emissions, but it doesn't have a target on emissions. So there we're at least asking, if you do monitoring of emissions, make sure you're also looking at those biogenic CO2 emissions and how many of them are stored. And ideally, they could, for example, include a climate neutrality goal in that legislation. They already have an energy neutrality goal. We believe a climate neutrality goal could be interesting, which alone could drive the scale up of CDR technologies in this sector. And the same a bit applies for the other two, the concrete recycling. It has the Waste Framework Directive, Construction Products Regulation, and also some standards on how much recycled concrete aggregates you can put in new concrete. We think in the Waste Framework Directive, for example, we propose there could also be a GHG emission target there, potentially even a carbon dioxide removal target in that legislation. And then public procurement is very interesting for concrete. We know almost 1/3 of the cement is purchased publicly through public procurement. So that also means for concrete. So if all that concrete, it would be purchased, including carbonated recycled concrete aggregates, that alone would already reach the full potential that we saw on the previous slide of Audrey. And then we have the mining waste. There we have the extractive waste directive. We have the waste framework directive, industrial emissions directive, critical raw material act. So there in the extractive waste directive could also put a target on how much GHG emissions it can produce when extracting minerals and treating that waste. And the industrial emissions directive, we also put that on the slide. It's mentioning which are the best available techniques for a sector. And it could also include there the mineral carbonation, for example. So as a conclusion, what did we cover here in the presentation? So to start off with the CDR potential in the sectors we have explored that, we showed that it meets or even exceeds their own sector emissions. We have showed that scaling CDR technologies could result in a minimal cost impact to the end user. So that's very interesting. They're already deployed at industrial size. You will see about that later in the case studies as well. But the limitations that we showed are preventing to reach large-scale deployment, which would be very welcome to reach the energy neutrality goal of the EU. And then the facilitating policy measures that can drive the business cases of these CDR technologies that we explored. And then embedding CDR policy making. Here we believe this could really drive a minimum deployment of CDR technologies in those sectors. And the EU or also other geographies could link that to their climate neutrality goals, for example, reflecting those goals also in sector-specific legislations. So finally, here on this slide, you can see all the people that contributed to the report intensively. So all the people here from our Deloitte team are on the slide. You can always reach out to us. Eileen, our partner, will also engage with the panelists in a bit. And then we have, of course, the very welcome contributions of the Carbon Gap team. We have Eli, who has been in the project for a long time, and then Alex and Rodika, who contributed a lot. And then, of course, we engaged with many companies. Many of you are also here today. And we also express our sincere gratitude for all the help and insights that you gave us to realizing this report. So it's out there. Go check it out. And then, yeah, we had room for questions and discussions. Maybe just one question if there is in the audience, but then I think we need to move already to the case studies.
Thank you very much. Fabien Ramos from DG Clima, European Commission. I have two questions for clarification. First of all, thank you very much for this work. It's really a great report, and the presentation you did is very clear. Though I still have two questions to be sure that I understand correctly. My first one is on wastewater treatment. I understood that you put alkaline material to remove or absorb the CO2, but is it the CO2 that is emitted by the treatment process, or is it, my question is it really carbon removal, or should we talk more about emission avoidance or carbon removal? This is my first question. And the second one is about waste and, waste, demolition waste and mining waste. What is the key difference between the two processes in terms of carbonation of the material? Is it, do you see some similarities? I'm asking that because you put it in two different categories, and my question is why two different categories if the carbonation process is similar in both cases? Thank you.
I think I can cover the first question that you had. So at the moment, within the carbon accounting frameworks, we see that the bacteria that are decomposing the organic waste within the wastewater, that CO2 that is emitted is not taken up into the accounting framework. So in essence, it's something that is not taken into account. So it's not the emissions of the process of, for example, the pumps of the wastewater treatment plant or etc. It's really taking out or preventing the emissions that are potentially going in the atmosphere because of the decomposition to get out, if that answers your question. And in essence, then the CO2 remains in the water.
So most of those emissions are biogenic, so from Essence, they started plants taking up CO2 from the atmosphere. And so today, most of those emissions are released back in the atmosphere. So it's a bit neutrality, although some of those emissions apparently are also fossil origin, which is not explored. So you need, if you keep that in the water, storing it there permanently, you're in the end extracting emissions from the atmosphere. So that's for wastewater. And then for concrete and the recycling and the mining waste management. So there indeed, those processes are very similar. So I believe one technology could also be used in the other sector. We split them up because that was how we set up the study. We explored the different opportunities in those sectors. The materials itself are also a bit different. So it could be that, there is some fine tuning needed on the technology for one waste stream compared to another. But the process itself could be fairly similar. Yeah. All right. With that, I think we can move to our first case study. So let me quickly introduce her. So it's Paula Manet. Paula Manet. She's Strategic Innovation Manager at OMEA. She has a PhD in environmental chemistry. She has lots of expertise in microbiology, chemistry, engineering. And with that, together with her experience in wastewater management, she's driving the development and innovation of the solutions they are building at OMEA. I'm very happy that she's here today and that she can present the work they are doing at OMEA to you all here today. Yeah.
Good afternoon, everybody, and thanks for the introduction. So today I would like to show you a pathway of carbon removal in wastewater treatment plant based on alkalinity enhancement using calcium carbonate. So before diving in, I would like to briefly introduce our company for whoever doesn't know. So OMEA is a global mineral solution company that is present, it's got sites across the major region. And our calcium carbonate and specialty mineral are used not only in water treatment, but in a variety of other industries, from construction, polymers, paper, food, and agriculture. So I work in the R&D department, as it was said, and we are headquartered in Switzerland. And as strategic innovation manager, I always look for new applications, such as water treatment-based CDR. So, as it was presented before, and you already know this, wastewater treatment plant offers an ideal environment to monitor and account carbon removal. So, as you can see for a quick graphic, is an example of a typical wastewater treatment plant. Because it's an engineering system, it's very easy to monitor the flux of carbon entering. And also, wastewater treatment plant exists everywhere near a populated area. So it collects the waste from household to industry and agricultural activity. This means that there is a constant influence of organic carbon in the system. However, wastewater treatment plants are far from being carbon neutral because they account for around 2.5% of global greenhouse gas emissions. So if we look at a global perspective, on a European perspective, we understand the potential of CDR in wastewater treatment plants. So the majority of the wastewater collected in Europe is processed through the wastewater treatment plant, which means that around 22 million tons of organic carbon becomes available in the system, which means that more than 60 million tons of potential carbon removal per year can be obtained in wastewater treatment plant. So in particular, as it was mentioned before, the secondary treatment where the biological process occurs accounts for the majority of the CO2 emissions in a wastewater treatment plant. As we said, in particular, direct emission comes from the biological decomposition of the organic pollutants, but also from indirectly from other processes, for example, nitrification processes to remove nutrients in the wastewater, but also by the addition of other chemicals such as inorganic salts that are used, for example, for flocculation or coagulation support in the system. So in Omnia, that's why in Omnia we have focused our effort in CDR, particularly on the secondary treatment, and we are already present in the wastewater treatment plant secondary treatment with our product, because calcium carbonate through Omnia Optical is majorly used as a pH buffering in the system to allow the biology to continue to perform in an optimized way, but also improve the floc formation and the waste activated sludge. As it was mentioned, the sludge is the composition, the bacterial composition in the secondary treatment, and also helping other functions such as the sludge bulking reduction. So as you can see, Omnia Optical is widely sold for this purpose across Europe, and we are also extending the market in the US. So it means that we already have in place the use of calcium carbonate, and to leverage this presence, we could implement a CDR easily without any with minimal investment, because the structure is already set up to use calcium carbonate. So how the calcium carbonate act? So we already seen this in the previous introduction. So the carbon dioxide that is generated from the breaking down of the organic pollutant reacts with the water to form acidic environment with carbonated acid. The addition of calcium carbonate buffered this acidity, but in the meantime also locked the CO2 from the biodegradation of the pollutant into a stable form of carbon, the bicarbonate ion. And this is expected to be locked for thousands of years. So to understand the potential of this approach in the reality, we have run a full-scale trial. So we based our trial on the concept, around the concept of additivity. So it means that we have increased the dosage of calcium carbonate in one of the lines, and we have compared it with the normal calcium carbonate routine used in routine operation. By this approach, we were able to calculate the effective carbon removal due to calcium carbonate. So, so increasing the dosage of calcium carbonate, therefore, allowed a more stable process performance due to a higher alkalinity, but also a higher removal of CO2. So as you can see, the system was already in place for a calcium carbonate addition, and is very simple, consisting in a silos and a pumping system that insert a calcium carbonate directly in the secondary treatment in what is called aeration basin. So we performed this trial in a municipal wastewater treatment plant based in Freiburg in Germany that served about 600,000 people population. We monitored the system for about 12 months, and 8 of these months we were used to account for the carbon removal. So how do we calculate it for the CDR? So we use an isometric frameworks that calculate the CO2 stored in the line with additional calcium carbonate, and we use 2 approaches suggested by isometry. We look at the solid phase method, where we took into account the undissolved particulate and the precipitation of calcium carbonate in the sludge, so in the solid of the wastewater treatment plant, but also a liquid phase method in which we evaluate the dissolved alkalinity leaving the wastewater treatment plant. This was compared to the counterfactual CO2, so the CO2 stored in the reference line, and also was corrected by the CO2 emissions, indirect emission, coming from the production and transport of the chemicals, of calcium carbonate, and also the energy consumption used in the wastewater treatment plant. As you can see, we monitor the system along the liquid line and also the solid line across the wastewater treatment plant. So both accounting methods resulted in similar, in comparable outcome. So during our trial, we could calculate 16 tons of CO2 removed per month in a single line, which would extrapolate to about 186 tons of CO2 that could be removed in a single line in a wastewater treatment plant per year. So if we extrapolate this into all the plant that it was composed of in a total of 8 lines, these would account for more than 1,000 tons of CO2 removed per year on the plant. So, but how much would be the financial burden for a wastewater treatment plant to perform the CDR? So during our trial, we estimated a few thousand euros that would cost to implement the CDR per month, which means that the full plant would face about €500,000 per year to support this CDR approach. However, if the CDR wouldn't be an add-on technology, but it would be embedded into the operation of the wastewater treatment plant, this cost would become negligible because it would imply a support from the taxpayer or around an average of €1 per year. So to summarize and conclude what we've seen in our study, so the wastewater treatment plant are an ideal environment for verifiable CDR. Our homeoptical alkalinity enhancement has delivered a dual value, both to stabilize operation in the wastewater treatment plant, but also by binding CO2 on the long term as bicarbonate. This was done with very simple implementation and a cost-efficient approach. The full-scale trial in Freiburg validated a meaningful CDR under real operating conditions. And however, despite this approach on CDR in wastewater treatment plant is quite straightforward and technically easy, we still face some challenges in a broader implementation, mainly because a wastewater treatment plant has limited awareness of the potential that this could offer. Finally, the current voluntary market CDR can be a bit fragile for the municipal planning, but embedding CDR into a utility service model and combined with some support from the regulatory framework would allow us to reach a long-term adoption of this approach and also deliver environmental benefits. So I thank you for your attention, and Nick and myself are happy to welcome any questions.
Sherwood from the Negative Emissions Platform, which is the industry association for the carbon removal sector here in Brussels. So while you were talking, I rushed to my calculator and did and did a little calculation, and I took I think it was 725,000 euros, and I divided it by 1,300 tons of CO2 removed, and I got to something like 550 euros per ton of removal. So I mean, you talked about if you were to do this, if you were to make the taxpayer pay for this, it would be very, very small cost because you have 600,000 people, for that facility, and indeed you could do it population level. But if that were some kind of on a kind of carbon market, presumably if you're looking at some kind of longer term pricing for carbon removals, I think we're all aiming for something that heads down towards 150, 100 or so euros a ton in the longer term. Is there a path to take the cost of this down from about 500 euros per ton to something closer to 200 euros, or is it always going to be really, really expensive compared to, you know, say biochar or other methods?
If you don't mind me asking, Chris, I mean, you probably saw there was a range of costs, right? Obviously on the one end we had the maximum cost. That was reflective of the cost of running the trial, you know, and the trial was on one of those lines, so we had to be, you know, mindful of the fact that we're showing true cost there of running the trial, one line, not the whole treatment plant. Yeah. The other end of the cost is where we think we should be able to get to when we grow it out over the whole plant, right? So obviously, you know, efficiency of scale, yeah, and also being able to increase the dosage, yeah, and then you're just purely coming down to the cost of your consumable, you know. There's all the other embedded costs in there in terms of, you know, laboratory analysis and so forth, which puts the cost of, you know, cost per ton of CO2 removed higher for small scale trials. But over a larger scale, that price comes down on the curve, and I think that was closer to somewhere between 150 to 200 for that. So, yeah, which looks more attractive, yeah.
All right. Thanks, Joanna, again for the presentation. I think we'll have to move to the next case study. Or was there another question? Yeah. Maybe one last question, but then the rest of the questions could be at the networking, just to stay within time.
Thanks. Awel from Anglo American. What is the status of your isometric registration or carbon credit issuance? Have you registered with them or?
Well, we went through, isometric is just to verify our carbon credit. We went to a third party to make the report and account, and isometric is verifying this account, and then issue the credit.
Yeah, I don't know if we have time.
Maybe a quick one.
Well, I don't know if it's going to be a quick one. If not, we can leave it for the networking. I'm Fabio from CWEP, European Waste to Energy sector. So our focus is on mixed residual waste, but we have an expertise in general on waste management. And actually was mentioned incinerator also for some sewage sludge. But my question here is about the chemistry. What I don't get is how you trap the carbon in the CO2. Because you start from limestone, you don't start from lime. So I was looking now at the reaction, but essentially the carbon somehow stays floated in the liquid phase.
Yes, but as bicarbonate. So, right. So as bicarbonate, that is a stable form. So it doesn't really release it out again.
So I get it. So from calcium carbonate, you become bicarbonate.
Yes.
That's the key.
Yes.
So it's essentially a mineralization process.
And at the same time, it's also
Yes. Right.
And
No, but I think this is important to say, because that's what I've been missing.
But the consequence is that the wastewater from the wastewater plant is alkaline, so it has a higher pH, a little bit higher compared to neutral wastewater. Now, wastewater is normally sour, so it has a lower pH, and thanks to this process, you will have a higher pH, say about 8. Is that correct?
Yes.
And is that not a problem from an environmental perspective for the waste, for the water downstream the wastewater? Why not?
Well, it's in the form of bicarbonate alkalinity, which is the most fundamental part of any aqueous system, so it buffers in both directions. You know, it buffers both, you know, acidic and alkaline in both directions.
And also, I think, I think the biological system in aerobic biological system that we saw, usually they perform optimally between 7 and 8. So of course we don't. Yes. So and also all the wastewater treatment plant.
And due to carbon equilibrium, as you push up the amount of dissolved calcium carbonate, your saturation pH drives down. So saturation pH of around 100 ppm of dissolved calcium carbonate would be 7.8. Where they were at 200 ppm, sort of closer to 7.4, right? So as you get down to 300 ppm, the more and more CO2 that we store into there as alkalinity, actually the saturation pH goes down closer to 7.
All right. Again, a big thanks for Paula here giving the presentation. Okay, our next speaker is Joanna Vieira Duarte. She's the lead of monitoring, reporting, and verification at Neustark. She has also a PhD in Earth Sciences, and yeah, she's basically an expert in the certification of carbon removal, and she's also leading that practice at Neustark, leading the certification of their climate projects, and basically pushing the carbon dioxide removal projects across Europe. So thanks again for Joanna for being here, and thrilled to see your presentation.
Thank you very much. Thank you everyone, and good afternoon, and thanks again for the opportunity for showcasing. Yes, do you hear me well? Maybe I need to speak a bit louder. Yeah, thanks for the opportunity of showcasing Neustark's work. Yeah, Neustark turns the largest waste stream into a permanent carbon sink. We are talking about demolished concrete, and the concrete sector as a whole is responsible for 8% of the emissions worldwide, and this is mainly due to the calcination reaction, which is a process where limestone is heated to high temperatures above 1000 degrees, and by this enables to produce clinker, which is one of the main components of cement that is then used to build concrete buildings and structures. And the good news is that this reaction is actually reversible. If we react or make react CO2 with the cement fractions in all demolished concrete, we can actually capture a significant amount of CO2 and bind it permanently. This is how we do it. Audrey already explained how this process works. I will go also a little bit in more detail. So at the end of life cycle of a building, the materials or the building is demolished, all different components are separated, so steel bars, wood parts, and also plastics are removed, and the concrete part are crushed into smaller fractions and can be repurposed into new products. For example, it can be used to build roads, it can be incorporated in concrete structures and produce recycled concrete, or ultimately landfilled. And simultaneously, we already saw before, biogas plants installed, for example, at wastewater treatment facilities can also enable us to capture CO2 that is produced as a waste stream out of the biogenic digestion of organic matter, and we can capture, liquefy it, and transport to these concrete recycling facilities. There, in the middle, Neustark installs the technology which then enables to make react the CO2, the biogenic CO2, and the waste materials. And the carbonated materials or carbonated concrete recycling aggregates can then be used for the same purposes as before, because they maintain the same characteristics and enable to reach the same physical and structure requirements of building structures. This process is permanent because it involves a mineral reaction. So through the process, the calcium hydroxides that are in the cement fractions of the material, they react with the CO2 and they recarbonate. So on the right, you can see actually some more rhombohedral shapes, which are actually calcium carbonate. These are calcite minerals that are formed on top or at the surface of these aggregates. Here you see also an example on how our technology is embedded into an existing value chain. So here we have one of these big concrete recycling facilities with a huge concrete aggregate pile on the back. And at the front, we can see the main components of the Neustark technology. We have a CO2 tank where the CO2 that is transported from a biogas plant is brought into. Then we have in the middle vaporizers and process control system, which enables to regulate the process. And on the right, a reaction chamber where the aggregates and the CO2 are reacting together. Overall, the storage potential of concrete demolition waste varies between 10 to 15 kilograms per ton. And if we take and consider the overall potential that these materials have in Europe, we would be talking about 2 to 6 million tons of CO2 per year. Neustark is not only working with concrete demolition waste, actually we work also with municipal waste incineration bottom ash or steel slags, which, because they have a higher alkaline component, enable to reach an even higher potential. So many waste streams exist out there that enable us and have significant potential for storing CO2, not only demolition concrete waste. The role of Neustark in the value chain is really to provide not only the technology, but the end-to-end approach. So we are financing and building liquefaction plants in biogas plants, we also take care of the whole logistic planning of CO2 and transport it to our sites. We design and sell the technology that enable us to, the technology and these plants that enable us to store CO2, and also take care of monitoring and certification of the climate impact, to then sell certificates and give them to our final buyers. In terms of monitoring quantification of the carbon dioxide removal, we consider mainly 3 processes in the value chain: the liquefaction, the transport of CO2, and the carbonation. Outside of these system boundaries are the process of producing biomethane, potential material pre-treatment and disposal and in-use, because these are already considered in existing value chains and can be excluded from an additionality perspective. But we can precisely quantify how much CO2 is stored. We measured with flow meters how much CO2 is being injected in the reaction chamber, and we can then deduct all losses that happen in the system. We deduct losses that are measured in the backflow, also with flow meters, and estimate losses in the void space that are released back into the atmosphere when we discharge the material. Moreover, we deduct also gray emissions, and these are for the use of fuels and electricity of this process, and also the infrastructure, so to build the infrastructure that is used by Neustark. And then we also deduct baseline, which is an estimate of the natural potential that there is in the material to absorb CO2 from the atmosphere without any accelerated carbonation or without any technological action. And then we can calculate the CO2 removed. However, it's important to also note that the CO2 removed is not yet the CDR, because many standards actually apply risk buffers, which allow to account for potential reversals or rounding mechanisms that lower down actually the CO2 removed on a conservative approach. And only then we have the CDR that we can hand in to our buyers. I put here the baseline and risk buffers with dashed line for a purpose. These are actually parameters that are being still highly discussed by standards and also by the CRCF. And it's important to note that variations in these 2 parameters influence or can highly influence business cases of projects and also economically feasibility of already existing ones.
But overall, if we put aside the buffers and only consider the gray emissions, we can see that the process can be highly efficient. Of course, it depends on transport distances and electricity emission factor of the country where we are considering our project. Neustark has around 47 capture and storage plants in operation, mostly localized in Switzerland, but also in other countries in Central Europe. And we have 12 more under operation currently. And we recognize mainly two CDR valorization pathways. The first one, and the most important, is when we sell CDR to compensate for hard-to-abate emissions. And these are mainly CDR that is sold on the voluntary carbon market to corporates, but can also be CDR that is sold to specific projects of cities or countries, or to direct emitters on a storage as a service modality. On a much more smaller, or with a much more smaller importance right now, is when we sell CDR with the concrete aggregate, or when our partner sells CDR with the concrete aggregate and contributes to the footprint of the concrete or the construction projects that they are building. We have some examples. For example, in Berlin or in Zurich and Bern, where carbonated recycled concrete aggregates were actually used for several purposes in different construction projects. But as you can see, the amount and quantity of material that was used is still quite small. And these are very specific and mostly financed by cities than other more generic approaches or employments. So to summarize and come back to the challenges that we see currently in scaling up the technology is, on the first place, the limited market demand that there is, and also limited incentives to use carbonated materials. And this is mainly lacking of regulatory frameworks because construction projects, they are usually, or the final user of these construction projects are generally not willing to pay a premium for these materials, and usually always the projects that are the cheaper are the ones that are being built in the end. On a second level, we also face the problem that we are always observing updates to MRV and risk buffers that are imposed by different certification standards and by the community out there. But these, as I mentioned before, affect the business case of existing and new projects and can actually make that projects that are already out there, they become economically unfeasible, and we have to stop them because there is no way to continue financing the old value chain, as I showed before. But I'm not saying that we shouldn't be accurate and we shouldn't be looking at MRV in a scientific way. What I mean is that we should not forget what is the purpose of our actions. We are all trying to tackle climate change and doing some climate action by dedicated activities. And what we need is some more pragmatism in creating these methodologies and policies to consider the actual impact of emissions we have today and the impact that this accelerated mineralization or other CDR activities also can have today. Yeah, and with this, I finalize my presentation. If you have questions, feel free to ask now or later. I don't know if you have time.
Yeah. Thanks, Joanna. Let's do one question and then we can move to the next case study indeed for time purposes. But yeah, many questions possible at the networking later. One question. You can go ahead, Fabian.
Question. Thank you. Thanks a lot for your presentation. first question on baseline. Do you understand correctly that the demolition of the building or the concrete material, the concrete, well, the element that you build with this concrete is out of the boundaries of your system when you do the assessment of the net removal that you get and from which you subtract the baseline? Do I understand correctly? And in the combustion, in the chamber when the chemical process happened, just was curious to know what is the source of the CO2, what type of concentration of CO2 you have on that for this process. Thank you.
Thank you. Maybe I start with the second and then I jump to the first. The purity of the CO2 that we use in our process is very high. It is nearly 99% of CO2 because it comes right after a liquefaction process in these biogas plants, and therefore when we vaporize the CO2, it's still at that first high purity level. For the first question on baseline, what we consider in our estimations is the exposure of the aggregates during the time that they are lying on a stockpile at the concrete recycling facility and afterwards in the next employment phase. So if they are used for or if they are employed for a concrete building, we will also consider the exposure of CO2 to that concrete building, but on a secondary lifetime of that aggregate, of that recycled aggregate, and not the original building.
One more then. We'll have a bit less coffee break, but yeah, I'm too kind.
I also asked the question before, so, but like Fabian, I'm also part of the expert group of the Commission on removals. One thing that we investigated at the last group is when we talk about this application, and for example, the case of incineration, you mentioned bottom ash is also an interesting material. The problem is that with the baseline is that this maturation process will happen anyway, right? So how do you account for that? Like, how do you make sure that we are genuinely creating a removal if that CO2 over a longer period of time will be sequestered and sucked anyway by the material? Of course, you can say we are accelerating that process and making it happen very shortly. But now with the isometric, or I don't know which standard you're using, how do you overcome that issue?
Yeah, right. We do estimations on the generally exposure that these materials have in nature and during that period of time. And then we consider how much CO2 can indeed percolate under those general conditions. We will not consider extreme cases where for example, we see in literature that the material is mixed several times to enhance CO2 to percolate through the material and actually be reabsorbed. We only consider the cases that we are looking and observe with our partners. So we do a average approach on that estimate. We can discuss afterwards more in detail. I'm happy to.
Yeah, maybe we'll have to move, but you can ask at the networking, just so we, yeah, because we're already much behind schedule. All right, thank you, Joanna, again, for the Q&A and the nice presentation. All right, our final speaker of the case studies is Awel Kulmagambetova. She's working at Anglo American. She's the principal carbon project development at Anglo American, and she built her career in this area, also on renewable energy projects, I understood. Yeah, she's driving business development, innovation, financing on all of this. And yeah, very happy to have her here as well and presenting the work she's doing together with the team at Anglo American. Thanks.
Hi everyone, thanks for giving the opportunity to speak. So we're going to talk about enhanced weathering in mining. But first, introduction to Anglo American. For those who don't know, we are a global miner. We produce copper, iron ore, crop nutrients, manganese, nickel, diamonds, De Beers jewelry is part of our group. Still making coal, and we produce, future enabling transition enabling critical minerals and metals. We explore, we find resources, we build mines, we operate them, we ship our projects to customers all over the world, and we also take care, we develop pathways for mine at the end of its life cycle. It only happened to me. Yes, we have a global footprint. We are present in more than 30 countries, with our main hubs in Latin America, Chile, Peru, Brazil, North America, in Canada, Southern Africa, Singapore, China. We have prospects in early stage project in Finland, and we are headquartered in London. We have 35,000 people approximately around the world working for us. So we have a pathway to carbon neutrality, and it's embedded in our sustainability strategy, which is built on 3 pillars. First one is a trusted corporate leader, healthy environment, and thriving communities, each of which then have 3 specific ambitions and goals. And our carbon neutrality pathway is embedded into the healthy environment pillar, and we have an ambition to produce metals and minerals, carbon neutral metals and minerals by 2040, sorry, that the world needs. Our scope 1 and 2 operational emissions reduction target is 30% versus 2020 baseline, and then ultimately become carbon neutral by 2040, limiting externally procured compensation to 10% maximum. And we also have scope 3 target, which is the carbon intensity of our steel, crude steel production from our iron ore. Now this will explain where CDR and enhanced weathering sits in our ski slope. So this is the emissions reduction pathway from the baseline from 2020 to 2040. And we have 4 main levers on for carbon emissions reduction. So first one is the energy productivity, which runs from 2020 to 2040. This is like the first top line. Second one is renewable energy, transition to renewable energy, which is about 45% opportunity reduction in emissions. And then we have the diesel replacement, which is a big problem because we have a lot of equipment on site which runs on diesel, and that's about 45% of our total reduction opportunity. And lastly, we have compensation, which is the last 10%, which is the, where's the point here, which is that bit here, it's 10%. So at the moment, we've developed our carbon compensation projects portfolio, and we are bringing one to life this year. Now, Project Earthstone. So enhanced rock weathering you're familiar with, pretty much same formula. The water reacts with CO2, forming carbonic acid. When that water reacts with the rock, it dissolves a solid mineral into an ion, which is a stable form of carbon, which can stay in the ocean for tens and thousands of years. Why it's called enhanced rock weathering is because the way to do it is to accelerate the natural process. You need to grind the material to increase the reaction contact surface. And this is what we do with this. This is what 30 million tons of nickel waste look like. There's a person on top of that mountain you can't see. We drive bus on this mountain. It's based in Brazil, in the state of Goiás. It's from our mine called Barro Alto. And this is a liability, both environmental, financial, social. But what's interesting, we have 34 million tons of this stockpiled at the moment. we have 2 million tons of annual production from 2 of their mines. This material has a potential drawdown of 0.6 tons of CO2 per ton of slag. We call this green slag because it's actually, when you look at it, it's green in color, which you can't see in the picture. It has a potential, so if we utilize this waste, we have a potential, at a steady rate, we'll have a potential to generate 500,000 credits a year. Now, this material weathers very fast, pretty much 50% in year 1, which is 10 times faster than the traditional basalt, which is very present in Europe. And the biggest advantage of this pile is its location, which is in Brazil. It's close to the mine. It's in a very hot and humid climate, and it's in the state of Goiás, which is the agricultural heartland of Brazil. And we have about 3 million hectares of farmland within the 200-kilometer radius of the mine. So the opportunity is huge. So how are we bringing it into practice? We've been running a trial in the Rio Verde region, which is about 300 kilometers from the mine, in order to prove that the science and the theoretical potential actually works. And what we did, we've ground the slag. At the moment, we don't have a facility on site to grind the slag to the required size. So we need to reduce it at least like 4 times, make it smaller. So we moved 20,000 tons to a grinding facility, a contract grinding facility. We then prospected farms, done due diligence on a few willing farmers who wanted to participate in the project. And we've spread the rock, the crushed rock on their site. And this is what uncrushed rock looks like. Oh gosh, sorry. This is what a crushed pile is. It's effectively like a powder. Then we moved our material to the farms, and we applied about 5 tons per hectare on a 4,000 hectare area. So we have 4 farmers participating in the project at the moment. That we then instrumented the areas with various tools. We have conventional lysimeters last year, the year before, and this year. But we also have found a fantastic company who are based in Germany. Some of you maybe know about them, but they're called 0x, and they have proprietary tech, MRV tech, which kind of drives the cost down of MRV stage massively, at least like 5 times cheaper than running it on lysimeters, because you insert that can into the ground once a year and you take it out 12 months later, rather than operating it with lysimeters, which you have to test every 2 weeks. So we've submitted a project design document to Isometric, one of the most reputable carbon registries at the moment. They've performed their audits, and our document will be out for a public review next week. We anticipate first credit issuance in May 26, and it'll be around 1,000 credits. It'll be the single biggest issuance on Isometric. And I think so far on the market, we have about slightly less than 700,000 ERW credits publicly, well, as in subscribed for publicly, with only less than 7,000 actually delivered. So watch that space. Hopefully we'll succeed with the first 1,000 credits from that side. And then we'll continue measuring it for 3 to 5 years. We say 3 to 5 because we believe most of it will be weathered in the first 3 years, so we don't have to do measurement up until year 5. And then we'll sell or retire credits for our own purposes. The idea is to sell credits to fund other carbon compensation projects in our portfolio to make sure that the program actually pays for itself, because we don't need to use those credits as of now. We will only need them in 2030 and until 2040, but while we are on that pathway, we want to co-fund other programs. Yeah, so first issuance hopefully in 4 weeks' time. Now, core benefits, obviously waste reduction and valorization of waste, environmental liability reduction. So we have, it will cost us a few $1 million to remove the stockpile from the surface. If we sell it, it becomes cost neutral. It's durable CO2 removal. We have agronomic benefits as well, both in terms of improving soil health and improving yield. People who participate in our trial, farmers who participate in our trial, reported significant improvements in the yield, in crop yield. Obviously, there's a lot of education and research. We have a few universities collaborating with us on the project from a QA/QC perspective as well. We have EU innovation at its core, being the German research, German startup, and we are solving a global problem by joining the forces. We've created a few jobs, and we will be creating even more. There's rural development, and there's post-mining livelihoods, because there are so many people involved in this project, and moving 30 million tons off the surface is not an easy task. And by the way, we have 30 more million tons coming from the ground over the life of the mine. So overall, it's 60 million tons. And this is what the CDR at scale actually looks like, because in this part of the world, we have a real estate issue. We don't have mines of the same size. So you need mining to produce CDR at scale, enhanced rock weathering at scale. Yeah, in terms of policy challenges, obviously not an easy fit for EU rules at the moment, firstly because of the geographical constraint and the availability of the methodology. The uncertainty around imported removals and use, plus additional pressures on buyers with the new regulation coming in, what is it, September 26, about green claims. I don't know whether that'll influence buyers adversely. The fragmentation across waste, product, land use, and carbon markets. Like, how do we classify the material? Is it waste? Is it fertilizer? Is it something else? And just general perception of mining and its byproducts. I mean, some people say, ooh, we are not going to buy credits from a miner because you guys are in extractive industry and one of the biggest polluters. We're actually not. Oil and gas are, but not mining. So there's big kind of mindset shift that needs to happen to bring ERW from mining at scale. And that's it. Thank you for your attention.
All right, let's also have one more question for AOL, and then we can go to the coffee break, where you can also network and also after the panel discussion. Any question in the audience? Otherwise, we go straight to the coffee break. Yeah.
Hi, thanks for the presentation. I had a question about the kind of the end product. So you have the product itself that presumably you're selling to farmers, and then you also have the removals, which are a separate product. Is that how are you selling the outcomes that you're generating?
So in that trial, we gave the material to farmers at a nil cost because they gave us the carbon rights. But we are also registering the project with a fertilizer regulator in Brazil. So once this is recognized as, like, they call it thermomagnesium, it could be a big kind of game changer in the agriculture.
So the farmers will be buying the product because it has value for them.
Yes.
And on top of that, you then separately sell the removal credit.
Yes.
Are you guys monitoring? Thanks. The crop yields as
Yes.
well as okay.
Yes. So we are doing biomass tests, we're doing soil tests, and like the plant uptake of the minerals and metals potentially. So far, like what we've submitted to Isometric in terms of risk, PTE or other trace minerals, it's based on our tests. It's well below the EU drinking water standard, but we're also going above and beyond that requirement to prove that it's safe by doing separate chromium nickel experiments in the laboratory.
Okay. Are you checking crop yield increases?
We're also checking crop yield increases.
Okay.
Yes. So far we've reported it's soy, corn, and we'll do a trial on sugarcane as well. These are the main ones in the region. And so far, the farmers who've participated in the trial, they reported yield increases between 5 to 25%.
Okay.
But it depends on the quality of the soil and how well
I think it also
managed.
depends on the crop as well.
Exactly.
Yeah. Okay. Thanks.
All right, let's go in the coffee break, and let's start again at 50. Let's say 50 past 3. Yeah, that's it.
Nice save. All right, welcome back. Welcome to the panel. I'm just going to briefly introduce everyone so we can skip the pleasantries and actually get into the deeper questions that I know you guys have all been itching to talk about. So, as a moderator, we have Eline Brigman, who is the Sustainability and Climate Leader at Deloitte Belgium. She has 20 years of experience in advising and supporting organizations in making strategic decisions considering complex strategic climate and social and governance risks. She's also responsible for sustainability, climate, and energy transitions at Deloitte Belgium. Our first panelist is Evard Pernot.
It's okay, everyone butchers it. So
Yes.
I won't get into that.
I also butchered his first name. He can probably say what it actually is. Anyhow, he is the Secretary General for the Zero Emissions Platform, soon to be the organization that's going to be known as Carbon Management Europe. They advise on industrial carbon management, which covers CCS, CCU, and increasingly CDR technology. He is one of the leading voices on industrial decarbonization and embedding CDR there. Then we have Fabian Ramos, who is the European carbon removal lead at DG Klima. I think a lot of people admire his work here. He's actively working on CDR policy and particularly focused on the CRCF regulation. And then we have Radika Vornik, who is one of, she's not going to quit because I mispronounced her last name. She is a policy director at Carbon Gap. She co-leads most of the topics that we work on here in Brussels, particularly with a focus on industrial policy. And, she's very much focused on unlocking CDR through business-aware and technically evidence-based policy recommendations. So, yeah, we'll go with that and enjoy the panel.
Thank you, Alex. So maybe let's start with you. Zero emissions platform, but what drew you into industrial carbon management and what are the ambitions of the zero emission platform?
So firstly, great to be here. Good afternoon. Thank you so much to Carbon Gap, to the whole team for organizing a great event, and also to Deloitte for publishing a really interesting report. And also to Alex for butchering my name. It's okay though, I do it as well. It's a very weird Irish name, so I apologize for that in advance. Zero emissions platform, we were founded about 20 years ago with support from the European Commission. And our focus is historically actually, which is why the weird name, which doesn't even include net zero, originally was really focused on decarbonizing the power sector. And I think most of that as well was really focused on how you could decarbonize coal power plants. About 15 years ago, that was really the focus. And things have changed since then. So I think my focus, at least, or how we've looked at it now, up until now, has really been sort of carbon capture and storage. There's also carbon capture and usage, and then I think a couple of years ago, certainly there was a lot more focus on direct air capture and storage and bioenergy carbon capture and storage. And that is very much actually the architecture of the industrial carbon management strategy that the Commission published in 2024. And I think, we decided to change our name really for two reasons. The first one was it's a terrible name, great acronym, but it definitely needed to be updated. And I think secondly as well, it kind of reflects the evolving nature of the space. I think the report itself was super interesting, at least for me, to learn about sort of technological processes that are very new. And I think also, I think carbon management itself is a much broader term than just the focus, at least that we have played on until now, which is sort of the chemical separation of CO2, you could say, and the permanent storage or usage of near pure CO2. And I think we're certainly very interested in all the other type of carbon management methods that are there. Certainly those that fit into the more permanent removals category. And I think, I'd be very happy to talk a little bit more about sort of the evolving nature of the carbon removal and carbon farming regulation certifications, and particularly what role these methods can play in scaling up the industry.
Looking forward. Fabian, I'm happy that I can now ask the questions. So you are a great contributor to the questions earlier, but you are called sometimes Mr. Carbon Removals, as I have been told. So can you maybe explain a bit what you do on a daily basis and also what the DG Klima ambitions are?
Yeah, sure. Is it working? I'm going to try this one. No, thank you. And first, I would like to say to Edward that I really like very much the new name of your organization. I can imagine, because the carbon management strategy was one of the initiative on which I contributed during my time at the Commission. So I started to work at DG Klima in 2015. So at the time of the preparation of Paris Agreement. And then very quickly we moved towards the long-term strategy. So for the first time, the European Commission decided to go for climate neutrality in 2050. And to go there, we saw immediately that we needed a lot of carbon removal, and I was behind the numbers at the time on these strategies. And this is where I started to work to think more actively about the role of carbon removals in European policies in the future. And after a great time spending crunching numbers in this context, I decided that probably carbon removal will be one of the very interesting fields to explore in the future and to try to develop policies on that. So that's why I came to this, but very good. I fully agree that today we focus on permanent removal, but we need to look at what is important is that we need to capture CO2, and we need to do something out of the CO2. It can be storage, permanent storage for carbon removal. It can be utilization of CO2 to replace it as a feedstock, so CCU. It can be for many different purposes and different type of CO2. But today I'm very happy to talk about wastewater treatment, to talk about concrete carbonation, to talk about what we can do in terms of enhanced rock weathering with waste from mining activities, because this is at the level of the CSCF, something that we would like to explore for the future. So very good to be here today. Thank you.
Okay, looking forward. Rodika, you work with Carbon Gap. What inspired you to really go into the field of carbon removals?
I'll go back a little even before that, just because I think as many people who came to Brussels, I arrived here 10 years ago, fresh from university, very much a generalist, looking for opportunities, believing in the EU project, which I very much still believe in. And then it was truly through happenstance that I sort of started to be involved by my bosses in climate and energy and environment related projects. And then now 10 years later, I cannot imagine a field of work that would give me any more satisfaction and reward and occasional frustration, of course. I don't think any of us suffer from lack of that, but it's all towards the greater good. And when almost 4 years ago, Alex actually reached out, we started a conversation about carbon removal, and I was really completely new to the topic. I just started being very interested in it from like a twofold kind of perspective. On the one hand, the whole idea of being part of an organization that is working exclusively on this umbrella of methods that are so essential to us to achieve our climate goals. That was a big part of it, but also the challenge of being part of something that is so new and at such early stage, and where, you know, I joined even before the CRCF proposal was out, so everything was so fresh and so new, and there was a lot of excitement about that and a lot of challenges, and I have to say that that was a big part of the motivation. So I'm very happy to be here.
Yeah, looking forward to seeing the reflections over the next 10 years, but maybe if we link it back to the net zero goals, what role do you see for CDR and going forward? What ambition should we have?
Good question. So I think if we are to take the climate law seriously, which we should, and our net zero climate neutrality target that we have enshrined into law, we see that carbon removal is not optional. It's really like a structural element of Europe being able to achieve this goal. And yeah, the numbers are the big question, right, on everyone's mind, and how to get there. And the reality is that at net zero point, as much as we will hopefully be able to reduce emissions, and we should have a very, very big ambition to do that, there will still be residual emissions. So we all know that. And the only way to balance those are through carbon removals. And there, the big question is also what kind of carbon removals. And this brings me to our favorite principle, the like-for-like principle. And our science team has actually very recently published a report on that. But the big thing that I want to say here is that not all CDR is the same, obviously. We have permanent, we have temporary CDR, and the like-for-like principle says that, you know, if you are emitting fossil emissions and then they're going to be in the atmosphere for a very long time, centuries to millennia and so on, the only way to balance them to reach durable state of net zero is by permanent CDR. And right now, if we're looking at the numbers, we're nowhere near kind of the ambition and the levels that we need to have. And I mean, the Commission has numbers, of course, in the impact assessment on 2040 targets, and there it was, I think, 50 megatons per year, if I'm not mistaken. And last year, together with VTT, so that is an amazing team of researchers in Finland, we conducted this modeling exercise where we looked at the contribution of carbon removal towards 2040 targets and beyond, and the numbers are staggering. So it's at least 100, maybe even more, depending on how ambitious we are with emission reductions. So just to say that the ambition is big, we just need to make sure that we create all the necessary policies to reach that kind of ambition. And that is why we're very excited about initiatives like the Virus Club, for instance, and we're excited about what's to come when it comes to compliance. And we're excited and hopeful for some kind of long-term strategy for CDR as well. It's going to be very important too. So yeah, there's a lot of work to be done to reach those numbers. But just to say again, number one priority, of course, emission reductions. But at the same time, you know, scaling CDR a big priority as well.
And that brings me to you, Fabian, in terms of ambitions, also setting targets, and then the role of CDR within reaching those ambitions. What is the position and the current outlook of the policy making with regards to CDR?
From where can I start? Maybe the most recent one is European Climate Law. And I think that we have updated our European Climate Law a few months ago. And in this update, we set an ambition for 2040. I already mentioned the climate neutrality ambition in 2050, where, as Rodika said, in our impact assessment, you can find numbers. We look at different scenarios because there is different ways to achieve climate neutrality. Some ways are relying in change in lifestyle, other ways are relying more in the development of the technology, and depending on which scenario you pick, you can have numbers indeed going from 50 million ton needed in 2040 to let's say 70, 80 million ton needed in 2050. So if you compare it to the total emissions that we have today, yeah, it doesn't look so big. But if you compare it to the situation where we are today at zero, basically for technical removals, this is very challenging to achieve a 50 million ton, or I'm not talking about 80 million ton. So this is the ambition set in the climate law, is to achieve a 90% emission reduction with a bit of flexibility potentially with international credits. And we are also looking at this possibility. Of course, first of all, we need to develop European carbon removals. We need them domestically, and that's why we have created the CSCF framework for the integration of carbon removal that is focusing on certifying a European project for carbon removals. But we also need to work in collaboration with other regions in the world, and it should not be only Europe. And our 90% target include potentially some external support for international credits. And we'll have to look at what kind of credits we could potentially buy. So when you talk about credits, it's about the origin of the credit, which part of the world. It's about the quality of the credit. By quality, it's not only the quality of the MRV, but also simply what type of the credits we want to buy. Only carbon removal emission reductions, of course. That's some implications, implication of cost, some implication of environmental activity, etc. We need to look at how to finance that, and we need to look at how to use these credits, how to integrate them in the overall policy framework. But okay, this is another discussion. Today, I think when we talk about CSCF, this is mainly, again, about domestic carbon removal and how to promote in Europe the development of all these projects. We saw in the presentation earlier today that there is a potential, and we need to work towards enabling this potential.
Thank you, Fabian. We already discussed the bigger picture, and Fabian hinted to it. We need a multiple solution. You focused on industrial carbon management and removal is one of that. A lot of the inputs or CO2 reduction potential comes from CCS and CCU. How do you link or match CCS, CCU, and then CDR technologies? What is your view?
Yeah, I mean, don't ask me about climate targets and numbers. I can't count past 5. I think, like, to kind of keep it simple, from our side, if you look at a lot of the infrastructure, and I think that was a kind of a focus in the report as a limiting factor, you know, it's fairly rudimentary stuff. It's pipelines, it's storage sites, and I think in a lot of the cases that we see, historically, you know, there's always been this sort of focus of reductions over removals. And I think, like, and I'm not disputing that point, at least in principle, but what we've seen actually in the market is a lot of the major storage projects, that is sort of geological sequestration, those investments have been enabled by removals in the last 2 to 3 years. Sorry, I'm checking this carbon gap thing. So I think, like, if you look at Stockholm Exergi, if you look at Ørsted in Denmark, you know, both of those projects actually enabled Northern Lights to get to phase 2 final investment decision. We've looked at Greensand, it's the same in Denmark with a lot of the biomethane guys. And I think that's actually the kind of the other point is really on that sort of CDR is has been very much an enabler for carbon capture and storage. It's kind of a weird patchwork of the way that the ETS works, and it's less of an incentive basically for fossil emissions reductions than it would be for removals. The main reason for that is honestly removals in many cases is upside. So you look at that, and that's your positive cash flow that goes into the project. For a lot of the fossil emissions, really it's about sort of avoiding the carbon price, a price which changes every day, by the way. So there's that sort of uncertainty about how to actually make your project bankable. And for a lot of industrial applications that we see, if you look at the cement sector, if you look at waste to energy, for those guys, you know, they're looking at maybe 15-20% of their, let's say, their CO2 that they're emitting could be biogenic. And that's actually something that they can monetize if they put it in the ground. Then if you look, I think probably the one I was most interested in today, honestly, was wastewater, mainly because of the biogenic part. And I think the biomethane stuff is sort of, to me, it's a total no-brainer. Like, it is basically free to capture. It's near pure. Stick it in the ground. There's projects that are planning to do that onshore in Europe for less than 40 euros a ton today, right? And I can tell you one of them is Danube in Hungary. And I think that's something that's fully integrated, so they don't even rely on a third party to do the storage. The challenge with those guys is they tend to be quite small, and that's kind of the second big point, is really focusing on aggregation. So if you want to reduce costs of carbon capture and storage, you can do that in capture, and I think a lot of the engineers will find out ways to sort of reduce the energy penalty, so to say, and that will come just through scaling. But the big cost that comes with infrastructure is size. And the issue with the pipeline is when you're going to lay a pipeline, the vast majority of the costs are actually laying the pipeline. So if you're going to do it, you're going to do big. But if you're going to do big, you need lots of users. And so who goes first? And are the first users going to pay for the 10th user? And what's the target? And that's the biggest problem right now, I think, in the broader sort of CO2 market, is like figuring out who's actually going to pay for this stuff. And if you're going to have it, okay, it's going to be, the unit cost is going to be really low. It's a 20 million ton pipe, but we're not going to do 20 millions from day one. So that's kind of like what's holding things up at the moment. And actually what we noticed is that a lot of the CDR projects, and I just came back from Norway last week where we did a conference there and looking at the operational projects getting going, the government is overjoyed with this voluntary carbon market that just came out of nowhere and seemed to have saved a lot of the projects that were struggling to get FID. And I think so that's really key. I think the other kind of last point, I think what we're looking probably for a little bit more certainty is not Fabienne's to-do list. It's very much, I think, for the folks in DG Energy who are in the lead on, is the sort of the CO2 market and infrastructure regulatory package. Right now, basically, we don't actually have rules on the EU level or European level, let's say, that dictate what tariffs you can charge for using this pipeline or this storage site. Are you allowed, is the same people who own the pipeline, are they also allowed to own the storage site? Some member states have taken some action on this already, but I think that's kind of what we're looking for, a little bit of regulatory certainty, not to completely freeze it with with regulations, but basically I think to have some sort of clarity around that would be very helpful for the users. And I think things will start to take off, but I think that sort of integrated approach of like a pipeline that's shipping CO2 doesn't really care where it's coming from more often than not. What matters is the ability of the users to pay. I think that's something that's kind of quite key and is honestly very surprising to me as someone who's been working in the sector for a few years, because I wouldn't have predicted that a couple of years ago.
We'll come back to that and also to the de-risking aspect, but maybe Rudika first on the 3 sectors that we just investigated. I heard from Alex that you already did a study on several sectors and the potential of CDR. So if you look at the 3 that we now selected, what is your view on the potential and potentially looking at other sectors, what we should be looking at going forward?
Study is a very strong word for actually our initial matrix. But I would like to first start with the fact that I really want to give massive kudos to the Deloitte team for this amazing work. Really, and also to our co-founder Eli, who was at the beginning of this project as well. So massive kudos to the team. And yeah, these 3 sectors, they're quite interesting to me personally also because they're not necessarily the usual suspects, so to say, when you're thinking about, climate-related conversation and so on. I think that is powerful in itself. And then if you're looking at the results of the report, it seems that what is very interesting is this potential, right? That, carbon removal potential could meet or even exceed the emissions of the sectors, which is very interesting if it's true. And what is powerful there is that you have this concept of sectors that could become net negative. And again, this is exactly what we need to be able to reach our goals, so to say. And again, what is interesting about this is that they are meeting, or the 3 sectors are meeting a few characteristics that are suitable, ideally, for integration, for CDR integration. And that's, they're highly regulated already, they are geographically fixed, and they are relatively shielded from international competition. But even more importantly, which I found very interesting, is this whole cost conversation, and that the cost impact is very low. And I think in the paper, there's the example of wastewater treatment and just a few euros per year per household, which is really a few cents basically per month per household. And it's really not that much. So altogether, yeah, very interesting results, and could be not only a niche opportunity, could be something bigger. And at the end of the day, and it's definitely worth looking into, and it's a start of a very important conversation to me, because at the end of the day, as we always say, it's not just one method, it's a portfolio of methods, it's not just one application, it's a diversity of applications. And we need all these little pieces of the puzzle to come together and to create and scale this wider sector. So yeah, great job, very exciting work.
Thank you. Fabian, maybe on the sector-specific characteristics, because indeed, for the study, it helped that it is a more regulated business, that it is more concise, that it's geographically locked in. How do you look at the regulation of CDR, and should we limit to only these characteristics, or is there a bigger potential?
I like very much the pragmatic approach on that. I think, and I remember actually a discussion that we had with Eli, we mentioned Eli just before, something like 2 or 3 years ago, I think, where we were discussing about this. What are the key sectors in the EU economy where we could potentially develop something to enable the development of carbon removal in a pragmatic manner. And we were talking about wastewater treatment. We were talking about a few other things. Can we use, yes, waste directive to do that? Can we use what we have on the construction sector? If we talk about what we are doing at the level of CSCF, you know that recently, actually on last Friday, we have published in the official journal the methodology for bio-CCS, for direct air capture and CCS, and for biochar. And already, this methodology can be useful for some of the things that have been presented today, because in the presentation on wastewater treatment, we saw 3 different steps for the treatment of the water. So the second step is enhancing the alkalinity of the water. Let's talk about that just after. And the third step is capturing the biogenic gas and storing it somewhere, and that I'm mentioning. It's a pure stream of CO2 that can be stored in CCS facilities on shore, offshore, whatever. And this is in the scope of the bio-CCS methodology, for example. But all this methodology is not enough. We know that there are more CDS, and if we want to really develop the potential of CDS of these subsectors that we were mentioning today, we need to look at other methodologies. And this is a work we have started to do. We had a discussion on enhanced rock weathering methodologies. We had a discussion on carbonation, so for concrete. And we had also discussion with water bodies. We approached it through the perspective of, I think we call that marine CDRs, but it could include, in my view, also rivers. It could include water treatment, etc. So we'll continue the discussion. We need to we have proposed some technical reviews of the different methodologies, and now we need a bit more concrete discussion, and from now what we can do on that, and in the next expert group meeting that we will have this year or next year, we'll continue this discussion. And we need that. We need really this input to understand where we could develop something that is robust enough to get the backing of the civil society in general, to not create, because if we start in the CDR space to develop things that are dubious, we are going to kill the CDR, and we have to be very strict on that. And we need to look at things where, yes, as I said, we need to be pragmatic, we need to be efficient, and to do something, even if it's very specific, something that can trigger something positive. The number you presented, it's about 16 million tons of potential in the wastewater, and I think this is a significant number. 16 million tons is not marginal at all. For the concrete, yeah, let's see also how much we can do with that. But everywhere where we can, there is a framework, a context that is favorable for the development of the carbon removal. I think it's important to see what we can do with that and to try to push toward it. So thank you again also for this report, and it will be a very good input paper in the future discussion on carbon removal, and I will make sure that it's on the agenda of the next carbon removal meetings.
Thank you, and it's indeed why we do such studies. We want to have an impact and make sure that it remains on the table and that we at least foster the conversation. But one of the limiting factors we already discussed is infrastructure. How do you, and the lack of infrastructure, and it's a massive investment, and it's a little bit the chicken or the egg. How big should it be in order to have sufficient infrastructure, but then still have a valid business model linked to that? But what are, according to you, the no-regret measures we could take in terms of that critical infrastructure today?
Okay, so there's the one real thing I'd always like to advise sort of policymakers and market participants on is how can you shorten your value chain as much as possible. So we have projects these days that are planning to start up, and I'm not like trying to throw shade at them or anything, but like if you're shipping it 1,000 miles to Norway, it's going to be quite expensive. So I think what's really interesting is there are a lot of great projects that are about to hopefully take investment decisions pretty soon, in key sectors where you're looking at kind of logistics chains of less than 100 kilometers between where the emission source is and where the storage site is. So if I told you that, okay, your emissions plant is going to stay there, so that's where your CO2 is going to be captured, and you know it needs to get to somewhere geologically, let's say, where it can be contained, and we'll talk about hopefully storage later on. The biggest cost component that goes into a capture, transport, and storage value chain that's sort of variable, or people don't really know how much it's going to cost, is the transport. Because you can kind of tell how much it's going to cost you to separate that CO2. You can give it a good idea of how much it's going to be to put it in the ground, but you have to figure out that middle part. And so the more projects that we see doing very close, near onshore storage, the better. And I think we have, for example, Aalborg Portland in Denmark, and also ANRAV, 2 projects. One is in Denmark, one is in Bulgaria. I would like to see those projects get, hopefully if they take investment decisions, I think they could really catalyze something in the industry to kind of get the people. I'm looking at Rob from Cement Europe in the audience, that these type of lighthouse projects could be very, very instrumental in kind of getting the industry to reassess how they want to do it. The other side of it, obviously, is, and the second point is really on the sort of hubs and clusters. So you look at like the big industrial areas, Antwerp, Rotterdam, obviously in the UK as well, there's major clusters planned, Ravenna in Italy. So these are major sites. The major cost reduction component there, like I said earlier, is on the size of it. So the unit cost is going to come down because you're looking at scales of like 15, 20 million tons. The real challenge with those is this, I hate the term chicken and egg, but it is this sort of this dance between where are the emitters and who's ready on time and this kind of thing. In many cases, for a lot of the sites that are not blessed, let's say, with being near an industrial cluster, the first option is probably the better, of how you can try to integrate your value chain. But it is really sort of one or the other, I think, in that case. And like I said, I think, for a lot of the traditional industries, and we talk even to people in the cement sector or in the waste to energy sector or the lime sector, removals is not, they have a biogenic fraction, which they know about, they have to report in the ETS, but they haven't really looked at that seriously, other than the big companies, they haven't really looked at that seriously as like an option for them to monetize. And I think that's one thing that's hopefully going to be really integral to it. And we'll maybe talk about it a little bit after, which is the Buyers Club, because that's a real focus where we want to try and match sort of what the government is funding, for example, in the Innovation Fund, with the Buyers Club that we want to help establish at the EU level for catalyzing private demand for CDR.
Maybe Fabian, can you pick on that one? Because I wanted to ask you a question on certification. I come back to that. But if we look at matching supply and demand and the Buyers Club, what is your perspective from a DG Klima point of view?
Yeah, so this is something that we want very much to develop, to enable the investment, private investment in carbon removals. We know that the timing is not. We do not have only good news on the voluntary carbon market. I think the voluntary carbon market has helped a lot carbon removal in the past, and I fully agree with what Edward said before. But we also that major players now decide to put the things on pause and to take one step back. Let's see, and it's not a total stop of investment in carbon removal, but there is this kind of signal. So we want all these carbon removal projects that we have. For instance, that we support somehow in the Innovation Fund to be able to take their FID, their final investment decisions. And this is why we want to develop this initiative on a Buyers Club. I'm not leading at the Digital Commission and at the European Commission on the Buyers Club. The person leading is in the room, Lucia, there. So if you have questions on that, you can talk directly to her. No, thank you. Nothing, Lucia. But yeah, the idea is exactly this one. The idea is to provide a framework, to provide something where there can be a discussion between buyers and public authorities, between buyers and suppliers, to help, again, this project to get the FID. I'm talking about the Innovation Fund, but we're also talking about other sources of funding, European funding. For instance, the EIC. At the end of your presentation, I think, you were showing that the capex was not so huge. The support that is needed is not so huge, and it's typically the order of magnitude that you could get through, for instance, the EIC, and some of these activities could be also supported by the EIC. Innovation Fund is a little bit bigger, well, significantly bigger for bigger projects, but we want to have some similar, well, some support as well, and some discussion on that.
And what about the setup of a certification system?
Certification system?
The certification, the carbon.
Yeah. So, yeah, of course, the CSCF is a key element for that. This is what you have in mind. The methodology that we are talking about today do not have yet a CSCF methodology. As I said, we have started the discussions on that, but we do not have yet a CSCF methodology. But it's very important that in the context of the Buyers Club, we don't forget these people that are developing this project, as I said, that are quite pragmatic and that could have a very good opportunity for carbon removal. So we need to find a way to design this Buyers Club to, of course, continue to support and help things that we have already started to support in terms of methodology, BECS, DAX, biochar, in terms of projects that have access to existing grants such as the one of the Innovation Fund. But we want to be inclusive, and we want also to support all types of relevant and potentially useful carbon removal in the future. We need help for that. We need help of the expert group in identifying what approaches that we do not have yet under our radar can be useful. And this kind of report is, again, very helpful in this sense. And this is typically the kind of thing that when we discuss with the CDR community, we are very much appreciated for us. So, yes, even if we do not have yet a certification methodology for this methodology, we'll be very happy if through this type of initiative, we can have a good discussion in the context of the expert group, and people behind this type of carbon removal could convince the experts of the expert group that this is something very useful, and experts including everyone that is in the expert group, because I think that is, well, carbon management Europe is in the expert group, to support and to push the Commission to develop methodology for this kind of carbon removal, because it's not only a decision of the Commission, is something that has to be agreed among the experts of the carbon removal expertise.
Yeah, I think indeed the multifaceted aspects and all the different expertises that are required need to come together and make sure that we can make it happen without over complexifying neither. So again, it's striking a balance of making sure that we have it right, but also that we move the needle, which is not always an easy task. Rodika, if we talked already a bit about operational barriers to further deploy CDR technologies. We also talked about the first-of-a-kind projects and the required funding to really make it, to boost it and make sure that we go to FID. What is your take on what needs to happen?
Yeah, thank you. So again, going back to the findings of the report, it's clear that the theoretical case is strong, but of course, it's when you get down to the detail of the implementation of developing the policies and so on, it's where it's becoming trickier and trickier. And there, what I found very interesting is the whole, which was presented brilliantly earlier, the whole accounting question and recognition question, and that many of those activities, of course, are not reflected in GHG inventories. So trying to look into that first would be very important, because if you cannot measure, there's little else that you can do as a first step. And then, yes, lack of real world kind of examples. We had a few here, but that's not much. And if we don't have more pilot projects and we don't have more first-of-a-kind projects, then we cannot get costs down, and then we cannot create confidence in this set of methods and technologies. And another big barrier, of course, is infrastructure, which Everett has brilliantly and eloquently and fully covered. But yeah, when it comes to facilitating measures, I think, and it's interesting to talk about mandates, of course. It was very interesting to see earlier also in the recommendations. But when it comes to facilitation, to us as Carbon Gap, targeted funding is always very important. Blended finance is always very important. But looking at it both from like early stage projects development and scale up. And I'm very happy that the conversation of the Buyers Club has, you know, we've discussed it earlier, wouldn't be able to add much than we supported fully. But I would like to spend a moment more on the early stage side of things and maybe jumping a little bit to the next kind of topic, which would have been around a series of knowledge gaps that still exist. Looking at the findings of the report, and I guess, you know, the accounting conversation also, I think another example that was given earlier was around all the potential co-benefits, but then there's so many questions around that. And that is the case, that's one example of these three sectors, but I would say it's an overall case for a lot of the CDR methods that we have, even some of them that are at a higher kind of development level. Higher TRLs. And there, I would like to shout out the work of a colleague of mine that is actually outside. It's Eloisa. She has put together this brilliant database with all the research gaps that when it comes to carbon removal. Hey, Eloisa's here. Yeah. So it's a full kind of database. It's like 300 and something, I think, research gaps and questions that we still need to figure out. I'm not saying the Commission needs to figure out everything. We all have to collectively figure it out, and that is in support to policymakers, of course, when they come up with their funding calls to be able to target some of the questions that are relevant, and there's a way of prioritizing within the database as well. And that brings me to the topic of like early stage funding or funding for research and innovation, which is very important when it comes to carbon removal. And there also Eloisa has looked into how much funding and how much money has the Commission, the EU as a whole, dedicated to carbon removal in the last budgetary cycle, and it's around 0.1%. So of the entire climate budget, which is good, 650 million, I think, but it's definitely not enough. And we also estimate how much funding should go into that for CDR for the next 7 years, again, for research and innovation. And there, the number, at least the lower kind of number, is around 2.6 billion. And the Commission also commissioned this report, which was published last year, which also confirms this number. And there's a bigger range there even, and goes up to 5.6 if I'm not mistaken. So what I'm trying to say with so many words is that there is a funding gap, and we need to figure it out. And that's not at all on only the responsibility of the EU. The member states should shoulder a big part of the responsibility, also the private sector as well. But something needs to happen, and we see that there could be opportunities within the now ongoing conversations on the next horizon. And there it would be amazing, first of all, to highlight carbon removal as a strategic priority when it comes to research and innovation. And then second, of course, to dedicate like more funding to it. And then third, to come up with some kind of, I don't know, like CDR mission or destination or something that would bring all these different kind of funding initiatives that exist, but they're fragmented within different parts of the DGRTD and so on. So bringing them together under the same umbrella would provide more clarity and would be certainly easy for, or easier at least for projects to apply to. So yeah.
Thank you. Already quite some interesting insights. What is your view on deployment? Do we need mandates? Do we need more incentives? We talked about the funding gap. What is your view? Or is there anything missing on the comprehensive inputs? No, it's okay. On the comprehensive inputs that we need to push for?
Look, I mean, I think generally when you want to get people to do stuff, you either pay them to do it or you force them to do it, or both. Right, so it's really not that hard when you start out from that basis. Europe is pretty good at forcing people to do stuff. Sometimes more forcefully. Sometimes good at paying them to do stuff as well. I think like with CDR, there's always been a huge focus on like credits, and everything has to be put into a ton, and then you buy the ton, and someone sells the ton. So I was really interested actually in the wastewater part about like how to embed it into the service. Because everyone's going to drink water, I presume, unless we all want to die. So, like, if you embed it into it as sort of a public utility, and I mean, obviously you'd need more than like one study, but like the study that you guys did in Deloitte was pretty, I mean, I'd pay for that as a surcharge. I mean, I pay for a lot of ludicrous stuff in public services all the time. to support, green this and that. So I think it's actually a pretty worthwhile kind of investment. And I think trying to operationalize that, the alternative would be sort of that the wastewater guys would have to finance a whole project and then produce credits, and people would have to buy those credits, and it'd be a mess. I think it's just so much easier to try and just embed it into something that all consumers are going to buy and use. The same kind of goes for other parts of the economy as well. At least in carbon capture land, there's a huge focus right now in the Industrial Accelerator Act, which is about sort of advancing lead markets. Lots of really good work there showing the cost of a house would increase by a couple of €1,000, but on a €500,000 house if you used very low carbon cement, or the cost of a car would increase by €100 or something like this. So I think generally consumers are happy. Most consumers are, and I count myself as one, obviously a biased one at that, but are generally happy to pay a little bit extra for something that makes them feel a little bit good, as long as they don't feel hoodwinked. And I think that's a really big thing, is many times I book a flight and they're like, oh, do you want to offset your emissions by planting some trees? And I'm like, really not, because I know that that's just not gonna help the planet. But I think that's kind of where the CRCF is very helpful, because now we actually have credit. Not to say that the isometric guys or whatever are non-credible, but we have an EU sticker on it, right? So that changed the game somewhat. I think if we're able to embed that somewhat into other parts of the economy, there will be a lot of carbon removal methods that require credits, because it's just easier to do it that way, like DAX or Bio CCS on a point source or whatnot. And especially because those guys are already in the ETS, it makes it easier to kind of figure out how to do that. But I'm really a fan now of actually looking at how to embed it in other parts of policy in a way. I think that's something that's quite interesting. And then the other point, and I kind of to the infrastructure piece that I sort of forgot to mention, and related to the Buyers Club, I think, is the Innovation Fund, and generally Europe is pretty good at identifying good projects that need to get funded, and the Innovation Fund picks great winners every year, and they're dotted all over Europe, which is part of the problem, is that we just sort of pick one-offs everywhere, and it's very hard for infrastructure developers to sort of then put that all together into sort of one pipeline that goes from A to B, basically. And I think what the Buyers Club will hopefully be able to do is at least a lot of the private buyers are we want to keep buying the stuff, but we also would in the future if governments were also buying it with us. And maybe they're not doing it right now, the Commission. Some governments, member states want to do that. I think Fabian wants to buy stuff, but I don't think he's allowed to. But I think a huge issue is sort of aligning public funding, right? Great projects that meet financial maturity criteria, but with private demand. And I think that's kind of something that for those projects that are not really looking at sort of this embedded policy frameworks and more in sort of how to finance something based on credits and emissions trading and whatnot, I think those ones would be a lot really nicer to see, is how we can really bridge that sort of private demand with public funding. That's been missing until now. So I'd like to see a bit more of that as well. So fun for everyone, really.
Fabian, maybe on the public procurement note, but also on the embedding, what is your view? Because we have very different forces. You hinted already also to the competitiveness agenda, and industries are having a rough time. So we are doing a lot to make sure that we can maintain our European competitiveness, which is under pressure. So how do we go about with the value chain risks, but also boosting demand via public procurement, and then making sure that we can try to embed, but also minimize the costs that come with CDR deployment?
Yeah. Well, yeah, I would be happy to buy carbon removals. Maybe it should be the objective before the end of my career at the European Commission to have a public procurement coming from the European Fund. No, but what I would like to say on this is that, yeah, we have to take into account the current context. And of course, ideally, when you talk about carbon removals, we know that carbon removals, this is a service provided to the society, and the system says this service has a cost. And if this is a service provided by society, it makes sense that part of the revenue that is collected for public services could be used to invest in carbon removals. But we know that there is a lot of demand for these revenues, and it's not simple at all. So what we can do, I think one very important thing is also to make sure that we do not put barriers to those that want to communicate about what they are doing, if what they are doing is good. And this is what we try to do. So we try to do, for instance, by giving the options under we are talking about concrete today, there is the Energy Performance Directive for Buildings Directive, where there is the possibility to report carbon storage in buildings. So we are using this framework in the CSCF. We are developing permanent carbon removal methodology, but we are also looking at things that are more temporary. And we are using this framework of energy performance of buildings to develop a methodology for timber construction and to have an alignment between the CSCF and this framework for construction, that the CSCF can be used, can facilitate the reporting of carbon storage in buildings, and then building owners can communicate on that and some kind of attached level to the building in the future. We are looking also how today the CSCF is very much about voluntary carbon market offsetting, etc. But we think that there is a potential for other type of business case, and we'd like to see if we could adjust some elements of the business case to make it easier for people that want to certify carbon removal happening in their value chain to be recognized also by the CSCF. We are also, we are trying to explore all the possible avenues. We have, this is true, we have mandates for synthetic fuels, for instance, in aviation. Should we have, and this is not the position of the Commission, it's just a question that is asked sometimes, is should we have a discussion about in the aviation sector? It's very difficult to reach the level of e-fuel that we have in our mandates, and should we think about being more flexible for decarbonization of the aviation sector, potentially? There is this kind of discussion. So this is not a very simple context. We have to take into account all that, I say it again. But if we really want to promote in the future carbon removal, we need to look at that. But I think it's easier to start from trying to provide more flexibility than to come with a stick and to put in the current context very rules that could be more difficult for it need to put in place. What is coming is the revision of the ETS, and before the summer, the Commission will come with a proposal on the ETS, where we looked at this question of carbon removals. So the link with the ETS is also an important one that could potentially give a signal that is awaited by the CDR community for a long time now.
Thank you for your very honest reflection on the current market. Maybe to close, I have for each of you a closing question before I open up to the public. Edward, maybe we already talked about coordination, collaboration. We have the sectors itself, we have technology providers, we have infrastructure operators, certification bodies, policymakers. So what can we do to bring all these different views together and facilitate collaboration to achieve CDR and the goals that go with it?
Join ZEP. Join Carbon Management Europe. No, join.
And next to that?
I think I'll join Fabienne's expert group as well, if he'll let you in. No, I mean, I think, I go to carbon capture conferences now, and very different people tend to pop up all of a sudden. And different technology providers, different vendors. All of a sudden there's sort of new technologies that come in that can help solve problems that previously you didn't even know could be provided. And also a lot of banks and sort of enabling kind of institutions that were there that even 3 or 4 years ago, we could never find a bank at these events. Now they're everywhere. And so I think as the sector matures and it evolves again, and I think, every kind of sector, carbon capture is definitely one of them that goes through these sort of hype phases, and then it goes down through winter. It's weird, right now things are quite a bit lower. Obviously the general attitude on climate is kind of weak, and or weaker, I think, in ways maybe than maybe 3 or 4 years ago. But also, I think there's a bit more realism in the place as well. Fabienne's points, I think, on sort of the refocus, let's say, on competitiveness, I think has helped a lot with that, in the sense that I think in the political architecture, people are focusing more on sort of cost effectiveness is higher, let's say, than maybe it would have been 3 or 4 years ago when it comes to decarbonisation. And that's actually been quite good for at least for a lot of the carbon management projects. So yeah, I mean, I think there's definitely, I think there's more than enough umbrella organizations and whatnot out there that will help to sort of bring in new perspectives and organizations. And I think that will, it tends to just evolve over time. I think people tend to refocus on this. The other part of it I think is really important is the geographical element. So like almost every event I went to, let's say 4 years ago, was in the North Sea region. But now actually there's like, we have the first storage project outside the North Sea that was permitted in Greece. We have actually a huge amount of projects that are emerging in Central and Eastern Europe and Southern Europe. And that's really important, I think, also politically, to kind of get those governments to kind of take action, rather than just portraying sort of carbon management as very much a thing for the Nordics and the North Sea, which it has been until now, unfortunately. So I'm a bit more optimistic about that.
Radhika, what is your view in terms of aligning all the stakeholders, but also scaling CDR?
I wish I had like a brilliant answer to this question. I'm not sure I do, but I'll be intentionally provocative, maybe a little bit, just by saying that I don't feel like we have a lack of communication platforms. There are so many in Brussels, and there's so many events, and there's so many groups, and there's so many, initiatives. It's about, are we communicating properly, and is it the best way of communication? Are we asking the right questions? Are we going towards common goals? And sometimes there's discrepancy within that, or maybe a difference in opinions, which is very important to drive the conversation further. But I think a very simple recommendation would be better communication. It's a very kind of couples therapy, I think, recommendation, but I think it applies very well to this case. And then secondly, bringing stakeholders together, and you've outlined a variety of them. And what would be an enabler for that from our perspective? It's at the end of the day a clear and stable policy signals, and just making sure that for the sectors and the companies, it is clear that carbon removal is here to stay in the way that is not a temporary kind of trend. It's actually a very important part of our pathway to reach our goals, and clarity on what are the different methods and how can they be used, and what do we do with the credits, and is the credits everything? Probably not. What else? What is the business case? There's so many things that need to be clarified for the different sectors to be able to start investing, and for the investors to do their job. So I think if I had to pick one, that would be the most important one to me.
Okay, clear. I like the couples therapy. So Fabian, how will we facilitate the couples therapy?
No, as Radhika said, I think there is already a lot of things wrong on that. I think what I have to say is, in the prep meeting that we had, we were talking about how the CDR sector could engage with European Commission, etc. on that to help and in a constructive manner to support it. I think the CDR sector is really doing a lot, I have to say, to be honest. I think venturing in the CDR space is truly a calling. It's something that, talking about the current situation, etc., this is providing, again, a service to the society. This is today, when you start to work in this sector, it's not, your first goal is not to make a lot of money. I think most of the people, if they start in this sector, is that they truly believe that they can be useful to the society and really do something for the good of everybody. And I think working now for many years in this space, this is something that struck me compared to some of the sectors. The sector is doing a lot. I think in terms of policy, there is also willing to go forward and to advance the case of carbon removals. But yes, it's a service to the society at a cost, and what we need is to try all together, and I repeat myself, I said it already many times, but how to be pragmatic, how to be efficient in our approach for carbon removal. We need to reduce the cost of carbon removal. If the cost of carbon removal stays at 400, 500 euros per ton, it will never fly. We'll never manage to have people paying for this service. So we need to reduce the cost. We have to discuss with the CDR community what are the low-hanging fruits where we can deliver already some significant numbers. If we talk about wastewater treatment, for instance, 16 million tons. It's not so big when you compare it to the total emissions we have today, but if you compare it to the number that we have in our strategy, 50 million tons, 100 million tons is already a significant share of the quantity of carbon removals that we need to achieve. If you look at, I think there is someone from the waste sector in the audience, and if you look at the potential of the capture of biogenic CO2 from the waste sector in Europe, and if you find some ways to systematically capture this CO2, it could also have a significant potential and help to achieve our objectives in terms of carbon removals.
One last thought. Linked to what I was saying earlier, first I want to say C3 DG Klima doing a fantastic job. What I would love to see is other parts of the Commission, part of this conversation, like DG Grow and so on. We've been trying to talk to DG Grow for a very long time. They have not answered. If you're talking to DG Grow, please bring us over. Yeah, please, can I join those calls? So yeah, I think what is also clear is that there needs to be a wider kind of, like bringing other parts of the Commission in this conversation to me is a very important part as well.
Well, first of all, let me thank you guys, because you are great ambassadors, all of you, in talking to and with the sector and making sure that we bring all the stakeholders together. I think we need to continue on that path. And I would like to give you the floor to ask some questions to the panelists, if you have any. There are some companies in the room, for sure. You have some reflections on what has been said. So feel free to join in the conversation.
Sorry about that. Chris Sherwood again from the Negative Emissions Platform. Thank you to Carbon Gap and to Deloitte for this really fantastic and very important work, I think. And if I look at this report, I think it's a sort of, to me, it seems like a hint to the European Union that we need to look at specific sectors, and I can think of at least a dozen, maybe 24 sectors. We've talked about 3 or 4 today. You know, we talked about wastewater, agriculture, mining, and construction. And in some cases, you know, you have 2 sectors involved in a particular type of CDR. But if we could look at a much broader range of sectors, then we could enter the territory where the European Union could be actually designing a plan for how to get to 100 million tons. And, you know, by not just by looking at one thing, but a much broader picture. So assuming that we need more plans with more sectors or more assessments of more sectors, who's supposed to do that? That's my question. Is that something that the European Commission should be doing, or that you would like, you know, Fabien, you would like to see NGOs and think tanks and associations like ours doing more? But I think there's more work like this that needs to be done. And my question is, who should be doing it, and how and when?
Yeah, so this is the kind of thing that we try to do not only for carbon removal, but for everything. When we are setting targets for the EU-wide economy, we are running a lot of modeling, trying to identify in each sector, and believe me, these modelings are going to very, very much detailed information, which sector can reduce emission by how much, which sector can do removal, generate removal, etc. But even if we are spending a lot of time and a lot of energy on this modeling, it's only modeling, and not everything is covered by the models. So, for instance, I'm not sure today, we were talking about wastewater treatment, I'm not sure that the current model that we have can model correctly the potential of carbon removals with wastewater. There is, we didn't talk much about biochar today, but some people also are looking at biochar. In the previous version of the model, biochar was not in the scope of the model. Now we have introduced biochar in the scope of the model. For instance, when you have a gasification of a biomass, you have a solid residue that can be biochar, and this is in the scope of the model. So we try to improve this model, but for that, of course, we need some input from research, from academics that are explaining, well, that are helping us to improve our modeling. And in this sense, what is often happening is that it's always start from stakeholders that are coming to us and explaining, oh, we looked at your models and we thought that there is a potential that you do not catch with these models, and look what we have done, we have this report, and we started a discussion on that. I'm not sure we are still doing it, or not right now, but this is anyway something that we do, but every few years, we are discussing the reference scenarios at the Commission. That is an initiative where we put stakeholders in the room and we discuss about our modeling, and we have an open discussion on how to improve our modeling. So yes, I would say, to conclude on that, I would say the reports that NGO, think tanks, academics, and others can do on this topic, on trying to see, even if sometimes it can appear at first sight as a niche for the generation of carbon removal, but where the cost can be quite reasonable and with the potential for a bigger impact in the future, I can only be extremely useful.
Yeah, I mean, I'm not really a fan of more plans. I think we have a lot of plans, I think, in general. I've also always sort of objected to CDR as this sort of separate thing. So, for example, if I'm like a bio CCS project, right, I can learn a lot more from a coal CCS project than I would from a forestation project or a biochar project. Obviously, we have this sort of similarity that we're both trying to take CO2 from the atmosphere, but how it works, how the project is financed, how you do all your permits, how you do the actual thing, everything is so much more similar to other things that happen in the sector that exists. I really like this report, and I really like it because it highlights different CDR methods in sectors that, at least until now, I haven't really heard a lot from. I think I've heard of Neustart before today, but in general, I think there's new sectors that can look at it as sort of part of their portfolio. But as regards sort of a grand CDR strategy or whatnot, I don't think that's necessarily needed. I think actually looking at the sectors that already exist and the people who they already talk to and the businesses and value chains, how they already exist in the world, is probably a better starting point than trying to sort of rearrange everything from a sort of a top-down deck because they all somehow remove CO2 from the atmosphere. But yeah, that's just my 2 cents.
Hi, thanks. I'm Amy from Anglo American. I think all the presentations today touched on demand needing to be there for lots of these technologies to mature and for the price to go down, as you said. So the international voluntary markets are incredibly helpful in this arena, but so are regulated markets. And I think the CRCF is going to be really helpful in this space as well. I think the challenge for us in the presentation that Earl gave is our project is in Brazil, and the nickel mining industry in the European Union could never achieve the scale that we were talking about in just one project. So I was wondering, you mentioned the EU ETS, whether or not you could see a future for international, highly durable carbon credits, CDR credits to be used in the EU ETS.
Yeah, so as I said at the beginning of this panel, we have in the European Climate Law 90% domestic target, and we need carbon removal for that. And that's why we looked in particular to European carbon removals, and we went with the CSCF framework that also has the characteristic that CSCF framework built on existing EU policies. So it's a very important element. And these EU policies, you do not have always an equivalent outside of Europe. We are building on the Renewable Energy Directive, we are building on CCS Directive, we are building on the Fertilizer Product Directive, etc., etc. And this is why the focus of the CSCF is mainly reviewing. Then, I also briefly mentioned it, we have the international credit, 5% of international credit, where we look at different types of credits, including carbon removals. Of course, the quality is extremely important, but the cost of the credits is also an element to consider. And we'll look at that in this year on how we, what kind of credits the European Commission could potentially, well, the European Union could potentially use to achieve its sector.
Super quick question about the models you were speaking of. Those are all public?
Yeah, the results of the model impact assessment are all public, so you can see the potential that we see on different sectors in this report.
And I can find them by
yeah,
digging
Commission
around
website and.
Okay, thanks. Or the carbon gap policy tracker. Shameless plug.
And it might even be easier to get it through the carbon gap policy tracker than the European website.
So, Rodolphe Nicole, I'm the Secretary General of the European Lime Association. So, thank you for the three of you. 2 years ago, I think we invited both Rodica and Fabien for a mineralization workshop at the European Parliament. At that time, you were already there. So, I would like to thank you for the, the continuous support to the topic in itself. To bounce back on what Chris just said, sometimes it's not only a question of modeling of sectors approach or whatever, and I'm glad to hear that you are challenging your own modeling to a certain extent. Because here, I mean, mineralization / carbonation, I mean, it's not a new topic. It's an untapped potential. And I like the name of your report saying that no wasted opportunities. Okay, there is nothing new. Polymer report that has been published already 6 years ago is on the table and is covering water treatment, concrete, and all the list. And I'm thanking the colleagues for bringing case studies because we are moving all in the same direction. So my point is sometimes we also need to change a bit the mindset and really get back to the I would say the chemistry in a certain extent. And there is an untapped potential with mineralization / carbonation, which is there. It's not only sector by sector, it's also defining well what's going to be, and we had already this discussion, so I don't want to insist too much on that, but it's very important. And I have a mixed feeling between the frustration of what we have done during the last couple of years, okay, compared to what we have achieved since the last discussion we had on this. So, but it's potentially 25% of all the CO2 emission of a sector like the lime one. So it's not small discussions at all. Well, the question is really to define, and it's also, I think, for carbon gap report and a couple of things I saw, but the potential of carbonation / mineralization is probably has to be reviewed or reassessed on this angle, because water treatment, for instance, concrete, and many others are delivering exactly on this basis. You see what I mean? And so far, I saw very few support on this specific topic. Oh, it's too expensive, it's too long, and so on. Well, I can name you a long list of other technologies that are very expensive and also very long, and sometimes definitely not permanent as mineralization and carbonation could be.
Yeah, just to say that this is why we started the work under the CCF on carbonation workstream. That's why to better understand all the processes and to see what we can certify under which condition. And then there is also, and Monica, you mentioned it already in the report, an accounting issue with IPCC. All the climate targets are based on the inventories of the UNFCCC, and there is a question, is it correctly accounted in the context of the IPCC guidelines? And you know that there is a workstream with a report to be produced in 2027 that can update all this kind of accounting. So there are two elements on that, is looking at what is possible to do and how we can use this mineralization, this carbonation process to help us to achieve our climate goal, what kind of technologies we can support, we can develop that will enhance the carbonation, and the word enhance is very important, and how our inventories fit for recognizing all these processes.
And just to finish on that, the Swiss authority mentioned last week that they put into their greenhouse gas inventory the recognition of carbonation and mineralization and figures. So, and two other members will do that very, rapidly. So it's already happening.
And this is very good, and it will also help the IPCC process if some countries already do that.
Yes, thanks. I followed very closely from the beginning all the discussions. I have, say, a questions less consideration. Mainly, it's a methodological remark on the work that has been done by Deloitte, really in the interest of the work itself. Just to avoid following also the discussions that we make a soup, especially when we talk about cost and the economics, just to avoid the easy takeaway that, oh, that actually this thing costs just a couple of euros per year per citizen, so of course we can do it. So the question is related to how to embed this cost in the final service. And today we're talking about waste management, which is actually my field. So my suggestion for what I've seen, and I was scrolling, I was looking the report as we were speaking, that I think we should make quite a distinction in the boundaries. And I will make an example for the wastewater treatment plant. It will be confusing for me to put in the same basket, for example, mineralization with the fact when sewage sludge are gasified or incinerated, and then that CO2 can be captured and put underground. Because we're talking about completely two different movies, two completely different technologies, two completely different value chains, meaning two completely different scales and costs. Because again, from what I've seen before, then it looked like that by doing sewage sludge, then I have this cost. And that's where we risk to mix technologies. So I think it would be good, again, in the interest, I hope this can be a constructive remark, to maybe make a separation. And this is related to a second point that I have as a suggestions, because of course, today we're exploring new sectors where this can be applied. It's super cool. But again, it's important to put the figures. It's interesting in terms of absolute cost, but also as a waste management practitioner and as somebody's in the expert group, I think it's more valuable to put figures in terms of relative cost, means kilos or ton of CO2 per ton of waste. And this, again, completely changes the picture. And the only figure that I've seen today that was given in this regard was by Joanna of Neustadt, that she was saying that with that process, that can lead to 10 or 12 kilos of CO2 per ton of waste. And that's where I think figures should be related in terms of relative. So then you can have a sort of equal comparison. And then on building up on that, then you could also throw economic estimations. But so my remark / question also to the panel, if this is just my opinion or it could be something shared also with the panel, that to say, okay, if I, in the wastewater sector, if I go for mineralization, I can have this savings and I can have this cost, or if I go for CO2 capture and then BECS, and then the whole discussions that Edward was doing on the value chain, but that's again something completely different movie. I have these different costs. Yes, we can do, but what I'm saying is I would avoid being also in the expert group to put everything in the same basket and to mix technologies, because then the takeaways could be a bit twisted.
Yeah, I appreciate that both suggestions a lot. Don't have necessarily a response to that. Just to say that I know that earlier I was saying we have enough conversations in Brussels, but I'd like to contradict myself. And earlier, Alex and I were talking at the beginning, midway through the event, and I was thinking, oh, this event should be a series of workshops. But actually, I was thinking, no, this is a good launch event, but we should have a series of workshops where we discuss things separately, you know, and we discuss them in depth. And then Fabian mentions the expert group and the fact that this conversation should happen in that framework as well. So for sure, as I said, this is very much the beginning of a conversation with this report. Really appreciate all the feedback. Let's keep in touch. Let's organize something as a follow-up and deal with these things point by point, because those are important considerations. I don't know if you have something punctual on what was said.
So we're probably going to have to cut the questions there because we're going to be kicked out of the venue in 15 minutes. I'm not even kidding. We're probably actually going to get kicked out. That being said, everyone, please join us in an applause for the panel. I would also
encourage you, just so if you have long-winded methodological questions, ask the Deloitte team. They've spent months on this. Talk about numbers. This is a city where most people don't even know what a marginal abatement cost curve is. So yes, let's elevate the discussion. Please join us with some light refreshments, and thanks for joining us. Cheers.
Thank you. And thank you.